What's up, everybody, and welcome back to OpenStax Algebra and Trigonometry, Chapter 11, Section 2, Systems of Linear Equations with 3 Variables. Let's do it. Question 1. Can a linear system of 3 equations have exactly 2 solutions? Explain why or why not. So I would say absolutely not to this, and the reason why is because a system of 3 linear equations, that's literally 3 lines. So imagine the possibilities. One possibility would be all 3 lines would be the same. Then we'd have infinite solutions, right? Another possibility is maybe you'd have 2 lines on top of each other and a third coming this way. But again, look at the point of intersection of all 3. It's only hitting at one spot. And then the other option is, right, like this, something like this, 3 lines going that way. Again, one solution. And the other third option is, of course, all 3 lines could be parallel. Then they'd never intersect, and then you'd have 0 solutions. So those are the 3 options. Done. If a given ordered triple does not solve the system of equations, is there no solution? If so, explain why. If not, give an example. So this is definitely not true. Obviously, you can be given a triplet of solutions of an x, y, and z value, and they may not solve may not be a solution to a particular system, but obviously there could be a different one. So I'm going to give you the example that they give in the back of the book. So in this case, for example, what they presented in the back of the book, 0, 0, 0 doesn't work, but of course there are other potential solutions. So that's how you do it. Done. Can you explain whether there can be only one method to solve a linear system of equations? If yes, give an example. If not, explain why not. So when we talk about our typical 2 systems of equations like we had in 11.1, right, we can graph, we can use addition/elimination, we can also use substitution. Now we come to a triple system, graphing is a little bit more difficult, right? Our graphs usually only have 2 variables, x and y. So usually what we're going to do is some combination, I would say, of elimination/addition and substitution. That's usually how we're going to want to go. Another way that we can do this is using matrices, but we'll get to that in a later section. So for this question, all we're doing is we're seeing if this triplet is a solution to this triple system where that's x, that's y, and that's z. So we're going to plug and chug into all 3 equations and see if it works. So 3 times 6 is 18 minus -3. You see I'm just plugging it in. Minus -3 is the same as plus 3. And then plus 3 times -5, which is -15. So the question is, first off, does this equal 6? 3 minus -5 is -12. 18 minus 12 is indeed 6. First one works. Let's plug it into the second one. 3 times 3 is 6, plus 5 times -3, that's -15, plus 2 times -5, that's -10. So the question is, does this equal 0? 6 minus 15 is -11, and then, or sorry, -9, excuse me, and then -9 minus 10 is not 0. So right off the bat, since this doesn't hit, it has to work for every equation. Since this only works for the first one and not the second one, this is not a solution. So we'll say no, boom, done. So for this one, we're going to see if 4, 4, -1 is a solution for all 3 equations. So let's start. This is, of course, x, y, and z. Let's plug and chug. So first we have 4 minus 4, right? Plugging in for x and y right here. 4 minus 4, that does equal 0. That works. What about this one? This is 4 for x minus -1. Does that equal 5? Yes, because double negative becomes a plus. 4 plus 1 is 5. Boom. Last but not least, we got 4 minus y is 4. Plug it in there. Plus z, which is -1. Does that equal -1? 4 minus 4 cancels out. -1 equals -1. This is indeed a solution. Yes, boom, done. So for this triple system, we're going to solve via elimination, aka addition, kind of interchangeable in this textbook. So what I'm going to do to solve this by elimination is I kind of like make 2 groupings. I group these 2 equations together, and then I group these 2 equations together. Then within these groupings, I'm going to try and eliminate the same variable. And it looks really easy in the top 2 to eliminate z, and I'm just going to do the same with the bottom 2. I'm going to eliminate z as well. So check this out. So to eliminate z, I'm going to multiply the bottom one by -2, and that gives me -4x minus 8y minus 2z, right? Distribute. Equals, and then -2 times 16 is -32. All right, now we're going to add these together, right? The top and this one. So 3x plus -4x is -x. -4y plus -8y is -12y. Of course, these cancel out. And then -15 plus -32 is -47. Okay, now let's look at these 2 equations. And to get the z's to cancel out, I'm going to multiply the top one by -5, and we're going to write it here. So, and I'm not going to write it out. I'm just going to sort of multiply in my head. So -5 times 2 is -10x. Negative 5 times 4 is negative 20y. Negative 5 times z is, of course, negative 5z. And then negative 5 times 16 is negative 80. And then we're going to write the second one as is. And now we're going to add these together, noticing that these are going to cancel out just like we want. Negative 10x plus 2x is negative 8x. Negative 20y plus 3y is negative 17y. And negative 80 plus 20 is negative 60. Okay, now I got two nice equations with only two variables. So this is now seeming like a typical dual system of linear equations. Now to solve these two, we're going to use elimination again. Again, I could use substitution, but why not? We'll use elimination. And let's get rid of the x's. So I'm going to multiply this one by negative 8. The reason why is because then it'll match up with this one. It'll be opposite, right? Because it'll be positive 8, negative 8. The x's will cancel out. So we're going to write that down here. Negative 8 times negative x is positive 8x. Negative 8 times negative 12 is positive 96y. And that's equal to negative 8 times negative 47. That's 320 plus 56, 376, positive, okay? And now we're going to add these together. These are going to cancel out. Negative 17 plus 96, that is 79. 79y equal to 316. We're going to divide by 79, and 79 goes into 316 exactly 4 times. All right, beautiful. So we got our first value, y equals 4. Now if I want to solve for x, I can plug it into one of these two xy equations just to make it easy. Actually, I'm going to make it even easier. I'm going to plug it in here. That's going to be the easiest. So then we have negative x minus 12 times 4, which is 48, equals negative 47. So as I add 48 to both sides, I have negative x equals 1, divide by negative 1, x equals negative 1. Now we got two solutions, right? We got y and we got x. So now we have to get z. So I'm going to plug these into any of these three equations. Let's plug it into the top one just for fun. So we got 3 times negative 1 is negative 3. 4 times negative 4 times 4, is negative 16. And then 2 times z, we don't know what that is. And this equals negative 15. Negative 3 plus negative 16 is negative 19 plus 2z equals negative 15. Add 19 to both sides. 2z equals 19 plus negative 15 is 4. Divide by 2 and we get z equals 2, which means our final answer in coordinate form, if I can find a little room here, would be negative 1 first because that's x, 4 second because that's y, and 2 third because that's z. That is how you do it. Done. So for this one, once again, we're going to use our elimination method for this triple system, and we're going to start by grouping these two together and these two together. And again, we're targeting a certain variable. In this one, I really think it makes sense to target the y because they're matched up nicely in this top one. So what I'm going to do is keep the top one as is, and then we're going to multiply the bottom one by negative 1, making it 3x minus 2y minus z equals negative 10. Then we're going to add these together. The y's are going to cancel out. We get 5x plus 3x is 8x. 4z minus z is positive 3z. And then negative 10 plus 9 is negative 1. Okay, now we're going to do the same thing here. We want to eliminate the y's again. So I'm going to multiply the top one by 3 to get 6y, the bottom one by 2 to get negative 6y. So let's check that out. 3 times negative 3x is negative 9x. 3 times 2y is 6y. 3 times z is 3z equal to 3 times 10, which is 30. Down here, we have 8x minus 6y plus 10z is equal to negative 6. All right, as we add these together, these are going to cancel out. Negative 9 plus 8 is negative x. 3z plus 10z is 13z equal to 30 minus 6 is 24. Now we got two awesome equations, and now we can use either elimination or substitution to solve for either x or y. Let's go with elimination, and we're going to solve for z. So I'm going to multiply this equation by positive 8, and we're going to write it up here. That gives me negative 8x, so you see the x's will cancel out. 8 times 13 is 104z, and then 8 times 24, that's 160 plus 32, 192. Cool. Now let's add it together. These cancel out. 3z plus 104 is 107z. And then we have 192 minus 1 is equal to 191. Divide both sides by 107, and we get this weird fraction, 191 over 107 for z. Now we can plug this back into this equation. That's arbitrary, right? I could also plug it into this one. It doesn't matter. But we're going to plug it in for z, and we're going to solve for x. So we got 8x plus 3 times 191 over 197. And then we got 3 times 191 over 107 is equal to 100, is equal to -1. Okay, now we can solve for x. So we're going to multiply by 3, which is 573 over 107 is equal to -1. Then we're going to subtract both sides by 573 over 107. This is a really bad numbers. But to make this easier, I'm going to make the -1 -107 over 107. Same thing, still -1, right? So then we minus 573 over 107 from both sides. That cancels that out. And then we have 8x is equal to negative, let's see, 680, I think, right? Negative 680 over 107. Last but not least, we have to get rid of the 8, so we multiply both sides, or divide both sides by 8, which is the same as multiplying by 1 over 8, and that cancels that out there. And 8 actually goes into 680 because 80 times 8 is 640, 5 times 8 is 40, so that's 84 is what it cancels out to. So then x equals negative 84 over 107. And 8 actually goes into negative 680 exactly because 80 times 8 is 640. 5 times 8 is 40. So 640 plus 40 is 680. So we can cancel this out to 1 and 85. So now we have x equals negative 85 over 107. You know, these are really bad numbers, but it is what it is. It's what they chose. Last but not least, we got to get y. So I can plug it into any of these 3 equations to get y. Let's just choose the top one just arbitrarily. So we've got, I'll write it out here. So we got 5 times x, which I substituted this in, 4 times z, which I substituted z in, and then 2 times y. Now let's simplify a little bit. So 5, we got to make a little bit of room. So we got 5 times negative 85. We already know that is, for, let's see, 425, right? So negative 425 over 107. Let's group these together. 4 times 191, that's 400, 367, 64. So that's plus 764 over 107. And we still have the 2y here, and this is equal to 9. But I think we're going to need a common denominator because this is probably going to be over 107. So 9 times 107 is 963 over 107. Okay. Negative 425 plus 764. This would be 339. So let's see if I can make some room here. We got 339 over 107 plus 2y is equal to this crazy thing, 963 over 107. Last but not least, or not, so we got 2 steps left. Now we're going to subtract 339 plus 963. That is going to be 624, I believe. 624 over 107. And then last but not least, we have to divide both sides by 2, aka multiply by 1/2. So that's going to divide 624 in half, which is going to be, let's see, 312, right? 312. So that means my y value is positive 312 over 107, which means in coordinate form, again, I'm going to have to make a little room because this one is a lot of work. We have a coordinate negative 85 over 107 for x. Then we got y, comma 312 over 107. And then we got comma z is 191 over 107. Boom, done. This is a tough one because we got these crazy fractions, big numbers. Usually it's not like that, but that's how it is here. This is the answer in the back of the book, so that's how you do it. So for this one, we're going to start by grouping these into 2 different groups of 2 equations, and we're going to choose a variable to eliminate. I feel like y is going to be pretty easy to eliminate, right? Because those are going to be easy to match up, and so are those. So we're going to start by multiplying the top equation by 3, and I'm going to do that mentally. We get 15x minus 6y plus 9z is equal to 3 times 4, which is 12. Second equation would be, we're going to leave as is. Now we're going to add these together. The y's are going to cancel out. 15x minus 4x is 11x. 9z minus 7z is 2z. Negative, or 12 minus 1 is 11. Boom, we got a nice equation with x and z. Now for the second 2, we're going to multiply the bottom one by negative 3. So the top one stays as is. Then we distribute the negative 3. We got negative 9x minus 6y plus 3z is equal to negative 12. Now we add these together. These 2 cross out. Negative 4 plus negative 9 is negative 13x. Negative 7 plus 3z is negative 4z. And then negative 1 plus negative 12 is negative 13. All right, now we got a nice system of 2 equations with 2 variables. look at this. We can match up the z's really easily. I'm going to multiply this one by 2, and we're going to get 22x plus 4z equals 22. And that's great because with this one, we're going to leave it as is, and check it out. The z's kind of match up as opposites. Now we're going to add these together. Those cancel out. 22 plus negative 13, that is 9x. 22 minus 13 is also 9, and divide by 9. Look at that. We get a nice whole number, x equals 1. Now we're going to plug it back into one of these two equations. Actually, I'm going to plug it into this one right here. So we're going to plug in 1 right there, and we got negative 13 times 1 minus 4z equals negative 13. These are going to cancel out. Well, look at that. That's going to be negative 4z equals 0, which means z equals 0. Last but not least, we're going to plug 1 and 0 in for x and z into one of these three equations. Let's do it into the top one. So 5 times 1 is 5, negative 2y. 0 times 3 is 0 equals 4. We're going to subtract 1 from both sides, or 5 from both sides, sorry. Negative 2y equals negative 1. Divide by negative 2, and y equals 1/2. So now we have a final answer in coordinate form. We have 1, 1/2, the y value, 0, the z value. That's how you do it. Done. All right, so for this one, we're meant to solve by Gaussian elimination. And to do that, we're going to have to convert this into a matrix. So let me show you how we're going to do that. So we're going to take the coefficients for x, y, and z in order. So I got 2, negative 1, and 3. And that equals 17. That's going to go over here. For the second row, we got negative 5, 4, and negative 2 equal to negative 46. And on the third row, we got 0 for x. We've got 2 for y, 5 for z, and negative 7 over here. So what we have to do now is we need to get this part to look like this. It has to be 1, 1, 1, and then zeros like so, the identity matrix. And then once we can flip all of these to this, whatever we'll have here will be the answers. The first one will be x, the second value will be y, the third value will be z. So let me show you how we can do that and the correct way to do it. So with Gaussian elimination, we can, just like any equation, we can multiply, everything by 2, divide by 2, whatever. We can do all these different things. So we're going to start with the top equation. And the first thing we're going to do is we're trying to get this to 1. We're going to flip that to 1. So we're going to divide everything by 2. And there's going to be a lot of work here. So we're going to say row 1 is being divided by 2. And that makes 2 divided by 2 is 1. Negative 1 divided by 2 is negative 1/2. We got 3 divided by 2 is 3/2. And then we got 17/2 over here. And everything else stays the same. Now, the next thing I want to do is I want to convert this to a 0. I kind of go in this order. So we got that to 1. Now we get this to 0. That one's already 0, so that's cool. So to get this to 0, we can't multiply or divide, right? If I multiply by 0, it zeroes everything out. We don't want that. But what I can do instead is I can take row 1 and I can multiply it by 5, right? So I multiply everything by 5 in row 1 and add it to row 2. Really, I'm adding this equation to this equation. Obviously, it's modified now, this one, but, and I'm allowed to do that. I can add equations together. So I say 5 row 1 plus row 2 is going to be the new row 2. Okay, so now we're going to do that here. So 5 times row 1, meaning 5 times 1 is 5, plus negative 5 is 0. That's what we want. 5 times negative 1/2 is negative 5/2, plus 4 is positive 3/2. 5 times 3/2 is 15/2, plus negative 2, that'd be negative 4/2, that'd be 11/2. And then 5 times 17/2, that's 85/2. This is negative 92/2 if you put it over 2, right? So let's see, 85 plus negative 92, that's negative 7/2. And then the bottom row stays the same. Now that we have a 1, 0, 0, now my next objective is to flip this to 0, okay? And it's not like there has to be an exact order, but I usually like to go down, 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 and so on. So to flip this one to 0, what I'm going to do is I'm going to multiply this second row by 1/3 and add it to the first row, right? Because that'll make this 1/2 plus the negative 1/2, and that's going to zero it out. So let's do that now. And this is just sort of how I keep track of it, right? I'm taking 1/3 of row 2, and then I'm adding that result to row 1 to get a new row 1. So 1/3 times 0 is 0, plus 1 is 1. 1/3 times 3/2 is 1/2, times negative 1/2 is 0. 1/3 times 11/2 is 11/6. And then if we have 11/6, we're taking 11/6 plus 3/2, which with a common denominator is going to be 9 6. That's going to be 26, which we can divide top and bottom by 2, so that's 10 thirds. And then negative 7 halves times 1 half is negative 7 6. And then we're going to add that to 17 halves with a common denominator, multiplied by 3 over 3. That is 51 over 6, and that's going to be negative or positive 44 over 6 divided by 2. That's 22 over 3. Next, I want to get this to a 1, and this is going to be pretty straightforward because we're just going to multiply everything by the reciprocal of 3 halves, which is 2 thirds. So 2 thirds times 0 is 0. 2 thirds times 3 halves is 1. There we go. And then 2 thirds times 11 halves is going to be 11 thirds. And then 2 thirds times negative 7 halves is going to be negative 7 thirds. So as you can see, these problems are pretty lengthy, so we're going to need some more room. So we're going to move down. All right, next we're going to hit this one and turn that one into 0. So what's going to work really nicely there, we're going to come over here, is we're going to multiply row 2, okay, times negative 2. And we're going to add that to row 3 and get a new row 3. So let's check that out. So negative 2 times 0 is 0 plus 0 still stays 0. Negative 2 times 1 is negative 2 plus 2 is 0. Boom. And then negative 2 times 11 is negative 22 thirds plus 5, which is the same as 15 thirds, right? With a common denominator is going to be negative 7 thirds, boom. And then negative 2 times negative 7 thirds is positive 14 thirds plus negative 7, which is the same as negative 21 thirds, right? Just getting a common denominator, and that's going to be negative 7 thirds. All right, great. Now we need to, I'm going to start back up here and I want to flip this one to 0. But actually what I think is going to be easiest is actually to flip this one first. I know we're going to go top down, but if you see this one, we want to get to 1, right? And I can do that first because I can multiply the entire third row by the reciprocal of negative 7 thirds, which is negative 3 sevenths. So negative 3 sevenths times row 3 will be our new row 3. So that's going to be 0, 0, negative 3 sevenths times negative 7 thirds is 1. And same with that one, that's going to be 1. So now we have our first answer, right? This one is a 1. That's in the Z column. That means Z is actually equal to 1. So we got our first value. So we're 1/3 of the way there. Okay. Again, we're going to need more room. So I'm going to move it down one more time. So we need to switch that to a 0 and that to a 0. So I think what's going to be easiest is I'm going to multiply the bottom row by negative 11 thirds, okay, because that's going to multiply that 1. Then we're going to be able to add that to the 11 thirds. So negative 11 thirds times row 3 plus row 2 is going to be my new row 2. So we're going to do it like that. So negative 11 thirds times 0 is 0 plus 0 is 0. Negative 11 thirds times 0 is 0 plus 1 is 1. Negative 11 thirds times 1 is negative 11 thirds plus 11 thirds is 0. That's what we wanted. And then negative 11 thirds times 1 is negative 11 thirds plus negative 7 thirds. That's negative 18 thirds, which simplifies to a nice negative 6. So look how beautiful these are all coming out to these nice whole, or integers, I should say. Okay, last but not least, we got this guy. And again, we're going to go back to that 1. That's going to make it nice and easy. So I'm going to multiply the 1 in row 3 essentially by negative 10 thirds. That's going to add to row 1, and then we're going to get a new row 1. So this is the final step here. So we got negative 10 thirds times 0 plus 1 is 1. Negative 10 thirds times 0 plus 0 is 0, and that's good. We want those to stay the same. And then negative 10 thirds times 1 is negative 10 thirds plus 10 thirds is 0. And we've got this one is 1, that one is negative 6. Last but not least, negative 10 thirds times this 1 is negative 10 thirds, and then that's going to be added to 22 thirds. That's going to give us a nice 12 thirds, which simplifies to 4. So now, if we write this in coordinate format, right, we got our 3 answers. The top is the x, and that's again lines up with that being a 1x. So we got 4. The y is a negative 6, and the z is 1. That's how you do it. Done. So for this one, we're meant to solve via Gaussian elimination. Once again, I set it up as a matrix with all the coefficients and numbers like so, right? 2x, that's 2, 3y, that's 3, and so on and so forth. Now, the first thing I'm going to do is I'm going to try to flip this to 1, right? We want that identity matrix, which once again looks like this. So we're trying to get this into that format. So first I'm going to multiply the top row by 1/2. So 1/2 times row 1. So everything else stays the same, but then row 1 becomes 1, 2 becomes 1, 3 becomes 3/2. Negative 6 becomes negative 3, and 1 becomes 1/2. Okay, cool. Now I want to flip this one to 0. So what I'm going to do is I'm going to multiply row 3 by 4 and add it to row 2. So we're going to say 4 times row 3 plus row 2 is equal to the new row 2. So we'll kind of symbolize it like that. So here we go. And we're kind of going in this order, right? Boom. So 1 stays as is, and so does 3. Now 4 times 1 is 4 plus negative 4 is 0. That's what we wanted. 4 times 2 is 8 plus negative 6 is 2. 4 times 5 is 20 plus 12 is 32. 4 times 10 is 40 plus negative 2 is 38. Boom. Okay, now we need to zero out this one. All right, so what I'm going to do is I'm going to multiply the top row by negative 1 and add it to the third row. So negative 1 times row 1 is negative 1 plus row 3, that zeroes out. Negative 1 times 3 halves plus 2 is positive 1 half. And then negative 1 times negative 3 is positive 3 plus 5 is 8. And then we've got negative 1 times 1 half, that's negative 1 half, plus 10 is positive 9.5. Cool. Okay, so next I want to get rid of the 1 half. So what I'm going to do is I'm going to multiply this row by negative 1/4, right? Negative 1/4 times 2 is negative 1 half. So we're going to multiply, we'll do it over here, row 2 times negative 1/4. And then we're going to add that to row 3 to get a new row 3. So these problems are pretty long. We have to keep making room and moving down. So bear with me. Negative 1/4 times 0 is 0 plus 0 is 0. Negative 1/4 times 2 is negative 1 half plus 1 half is 0. Negative 1/4 times 32 is negative 8 plus 8 is 0. Look at that. And then negative 1/4 times 38 happens to be negative 9.5. Okay, this is very interesting. We have one row that is completely zeroed out. This is a situation where we're going to have an infinite solution situation, right? And so now once we get to this point, what I'm going to do is I'm going to take this and I'm going to transfer it back into equation format. So for example, for this top one, we have 1x plus 3 halves y minus 3z is equal to 1 half. For the second one, we have 2y plus 32z is equal to 38. So what we're going to get now is we're going to have to get relative values, meaning I'm going to try and get everything in this case in terms of x. So I'm going to show you how we're going to do that. So I have a 3 halves y and I have a 2y here. I have a negative 3z and a 32z here. So I'm going to try and like combine these in some way to basically get rid of the y's, for example. So I can get rid of the y's if I multiply the top equation by negative 4/3. So watch what happens. I get negative 4/3 x, then I get negative 4/3 times 3 over 2 is negative 2y. You see how these are matched up, so when we add them together, they will eliminate. And then negative 4/3 times negative 3 is positive 4z equal to, and then negative 4/3 times 1 half is negative 4/6 or negative 2/3. Now if I add these equations together, check this out, this cancels out, and I get negative 4/3 x plus, let's see, 4 plus 32 is 36z is equal to 38 minus 2/3. That's 37 1/3. But I'm going to write that as an improper fraction. So 37 1/3, let's see, 3 times 37, 90, 21, 111, 112 over 3. All right, so what we're going to do is we're going to try and get z in terms of x here, okay? So I'm going to isolate z. So first, I'm going to add 4/3 x to both sides. So now we have 36z is equal to 4/3 x positive, right? Because I added it over here, plus 112 over 3. And we can rewrite this to have, they have the same denominator, so we can kind of make this one giant fraction like so, make it a little simpler, all over 3. Last but not least, we divide by 36, which is the same as multiplying by 1 over 36. And that would be 3 times 36 on the bottom, which is 90, 18, 108. And now we can simplify this, right? We can divide everything by 4. 108 divided by 4 is 27. And on top, we're going to have 4 divided by 4, which is 1x. And then we have 112 divided by 4, which is 28. So here is my z value. We're going to move down again because we need more room. Now to get y, what I'm going to do is, since I know that z equals this expression in terms of x, I'm going to take that equation up top, 2y plus 32z. But instead of z, I'm going to substitute this in because this does equal z. And this all equals 38. So now we can get our y value in terms of x. So what I'm going to do is I'm going to first move this entire expression over to the other side by subtracting by that. So we got 2y is equal to 38 minus 32 times x plus 28 over 27. And then I'm going to divide both sides by 2. So I got y is equal to 19 minus 16 times x plus 28 over 27. Let's see if we can simplify this a little bit. So then I'm going to distribute the 16 up top, boom, boom. I got y equals 19 minus 16x, and that negative distributes, right? Well, actually, let's make it like plus and then negative 16x, and then minus 16 times 28, which is 448. Then this is all over 27. And then if I want to consolidate and combine like terms or make a fraction, I should say, I'm going to put 19 over 27 as well. 19 times 27 is 513. So that becomes 513. And then now everything is over 27, right? Minus 16x minus 448. We can simplify a little bit here. 513 minus 448 is 65. So finally, we have 65 minus 16x over 27. So this is my value for y. Now let's put it in coordinate format, make a little bit more room once again. So of course, x is x. We know that y is this value, 65 minus 16x over 27. And last but not least, z is this value in terms of x plus 28 over 27. That's how you do it. Done. So once again, with this one, we're starting with Gaussian elimination, putting it into a matrix, and you notice I put the coefficients of the variables in that same order in this structure. Now, again, we're trying to get that nice identity matrix in this part, which is a diagonal row of ones and then zeros in these other spots like so. All right, let's begin. Now, first, if I want to get this value to 1, let's make that our first objective. I can just multiply the top row by 1/2. So leaving everything else the same, multiply this by 1/2. That's 1. That is 3/2. 1/2 of -4 is -2. And of course, 5 becomes 5 over 2. Next, I'd love to get this to a 0. And I can do that by multiplying this by 3 and adding it to row 2. So our next move is multiplying 3 against row 1 plus row 2 is going to equal the new row 2. Let's check it out. So 3 times 1 is 3 plus -3 is 0. That's what we want. And then we got 3 times 3/2 is 9/2 plus 2 is 13/2, I believe, right? Because 2 is 4 over 2, and then plus 9 over 2 is 13 over 2. And then 3 times -2 is -6 plus 1 is -5. And 3 times 5 over 2, that's 15 over 2, or 7.5 plus 11 is 18.5. I know I'm kind of mixing between decimals and fractions, but that just seemed easier to write, so we're going to roll with that. Next, I'd love to flip this into 0, and that's pretty easy. I can just add row 1 straight to row 3. So let's check that out. Row 3 plus row 1 to give me my new row 3. So 1 plus -1, that's 0. 3/2 plus 5, that's like 10 over 2, that's 13 over 2. And then we've got -2 plus 3, which is 1. And then 5/2 plus 4. 4 is like 8 over 2 plus 5 over 2 is 13 over 2. Great. Okay, now as we keep going, we'd love to switch normally this one to 0, but I also want to switch this one to 0. And I feel like that's going to be easier because look, I can just multiply row 2 by -1 and add it to row 3, and that's going to work. So I'm going to scroll down now. We're going to make some more room down here. So we're just negating row 2, adding it to row 3, and that's giving us our new row 3. -0 plus 0 is just 0. -13/2 plus 13/2 is 0. -5, which is 5, plus 1 is 6. And then -18.5 plus, this would be 6.5. -18.5 plus 6.5 is -12. Now, this is pretty interesting because even if I want to work on this row, look at this. I'm almost there. I've almost got a 1 here. I can just multiply row 3 by 1/6, right? 1/6 of row 3. And we've got our nice 1 in that spot. So then we got 0, 0, because those multiplied by 1/6 stay the same. 1/6 times 6 is 1. That's beautiful. And then 1/6 times -12, that's -2. By the way, at this point, we're actually in a good spot. I already know that 1z is equal to -2, but we're going to keep going. What I'm seeing that's going to be easy next is I can flip this one to 0 simply by multiplying this by 5 and adding it there. So 5 times row 3 plus row 2 will be excellent here. Let's do that next. So 5 times row 3 plus row 2 gives us our new row 2. Let's check it out. So 5 times 0 plus 0 is 0. 5 times 0 plus 13/2 is 13/2. And 5 times 1 plus -5 is 0. 5 times -2 is -10. plus 18.5 is 8.5. Now, all I need to do is I need to flip this into 1, right? And then we'll kind of have this entire diagonal row of 1s. And the way I'm going to do that is multiply it by the reciprocal of 13 over 2, which is 2 over 13. So coming over here, I know we're kind of going back and forth, but we're going to take row 2, and we're going to multiply it by, sorry, not 13 over 2, 2 over 13. So let's check that out now. So of course, 0 times 2/13 is 0. 2/13 times 13 over 2 is 1, and then 0 times that is 0. And now we get to the 8.5. So I'm going to flip it back into an improper fraction. So 18.5 is 17 halves, okay? And then I'm going to multiply that by 2 over 13. The 2's are going to cancel out, and we get 17 over 13, and that's going to be our value for y. So we almost got it. We know our y value, we know our z value. All we need now is x. So first I'm going to zero out this guy, and that's pretty easy. I just multiply the bottom row, the third row, by 2 and add it to row 1. So let's make a little bit more room. We're going to do that over here. So 2 times row 3 plus row 1 gives us our new row 1, and let's do it. So 2 times 0 is 0 plus 1 is 1. 2 times 0 is 0 plus 3 halves is 3 halves. 2 times 1 is 2 plus negative 2 is 0. And then 2 times negative 2 is negative 4. And then plus 5 halves. Let's just do it in decimal format. So that's 2.5 plus negative 4 is negative 1.5. We'll flip it back as needed. All right, now we're down to our last one that we got to flip to a 0. This is going to be nice because all we got to do is multiply the second row by negative 3 halves and add it to the first row. So we'll do that here. Negative 3 halves times row 2, right, plus row 1 equals our new row 1. Let's check it out. So negative 3 halves times 0 plus 1 is 1. Negative 3 halves times 1 plus 3 halves is 0. Beautiful. And negative 3 halves times 0 plus 0 is 0. And then we get to this tricky little fraction. Let's make a little more room. So we got negative 3 halves times 17 over 13. That would be negative 51 over 26. And what we're doing is we're going to be adding that to negative 1.5, which I'll turn it back into a fraction now, is negative 3 halves, okay? And I'd love some common denominators here. So I'm going to multiply top and bottom by 13, so we get 26 as a common denominator. So now I get negative 51, basically minus 39, all over 26. Negative 51 minus 39 is negative 90 over 26, which reduces to, if you divide by 2, negative 45 over 13. So now we have our triplet. Let's put it in the nice format. We got x is negative 45 over 13. We got y is 17 over 13, and z is negative 2. That's how you do it. Done. So for this one, we're going to start with our nice matrix. And again, I just put all these coefficients, right? X has a 1 coefficient, so the 1's there. That y is 1, and so on. One thing to point out, though, is the second and third equations have no x's. So I put a 0 in for the x coefficient, right? 0 times x would be 0. Okay, let's start. Now, this is pretty cool because we already got a 1, a 0, and a 0 at the start. And that's pretty good because what we generally want is, you know, this diagonal thing of 1s and then 0s in between. So it's already like we're partially there for this column. So the next thing I'll flip to 0, how about, is negative 16, right? We need this to be 0 and that to be 0, but that's just going to be easier. I'll do that first by multiplying row 2 times 8, right? Row 2 times 8, and then we're going to add that to row 3 to get a new row 3. So let's write that out. So 8 times 0 plus 0 is 0. 8 times 2 is 16 plus negative 16 is 0. Nice. 8 times 3 is 24 plus negative 24 is 0. And then we got 8 times negative 14. That's 80 plus 32, which is 112. And negative 112 plus negative 112 is negative 224. Okay, but we got to stop here for a second, right? If we had a row of all zeros, that's fine. We could keep going, and maybe we'd have infinite solution situation. But this right here is our indication that we have a problem because we have 0x plus 0y plus 0z equals negative 224 somehow. That doesn't make any sense. It's basically saying 0 equals negative 224. This is not true, which immediately takes us to the fact that this is a no solution situation. That's how you do it. Done. So this one, we're starting with this in matrix format, right? All the coefficients are here, right? Like so. And the reason why I have 0 here is because there's no y in that one. So it theoretically has 0 times y, right? 0 is the coefficient. Okay, now let's get this to that nice matrix identity where we have ones like that, and then zeros filled out as so. Okay, so the first thing I'm gonna do is I already got a 1 here. Let's flip this to a 0. I'm gonna multiply the top row by -2, and I'm gonna add that to the second row to get a new second row. Let's go. So -2 times 1 plus 2 is 0. -2 times 1 is -2 plus -1 is -3. -2 times 1 is -2 plus 3 is 1. And -2 times 0 is 0 plus 0 is 0. All right, cool. Now let's flip this into a 0. We can do that nice and easily by multiplying row 1 by a negative and then adding it to row 3 to get a new row 3. Let's write it out. So -1 times 1 is -1 plus 1 is 0. -1 times 1 is -1 plus 0 is -1. -1 times 1 is -1 plus -1 is -2. All right, cool. So next I'm going to flip this value into 0 by taking row 3 plus row 1 to be our new row 1. So let's check that out, make some more room. So 0 plus 1 is 1, -1 plus 1 is 0, and -2 plus 1 is -1. Of course, 0 plus 0 is 0. And it's looking like these are not going to really change anytime soon. So that's kind of an interesting thing to note right now, but we're just going to keep going with the typical protocol. Okay. Now I'd love to flip this to a 1. I can do that nice and easy by multiplying the second row by -1/3, right? So -1/3 times the second row, we'll do that nicely. So here we're gonna make a little bit more room here. So -1/3 times 0 is 0. -1/3 times -3 is 1. That's what we want. -1/3 times 1 is -1/3. And of course, times 0 is still 0. Great. And now I'd love to flip this one to 0, and literally just going to add row 2 to row 3 to get our new row 3. So let's do that here. 0 plus 0 is 0. 1 plus -1 is 0. -1/3 plus -2. Let's make that 6/3, -7/3. And then we still got 0 here. So like as we're going through, you can kind of see it doesn't look like these are going to change anytime soon. It's really looking like X, Y, and Z are probably all going to have to equal 0 for this to work out. But we're going to keep playing it out as is, okay? So now it might seem really convenient to flip this to our 1 to get our nice diagonal of 1s. So all I'm going to do is multiply the third row by -3/7, the reciprocal of this. So -3/7 times row 3 is going to give us the following. So we got that times 0 is 0, that times 0 is 0, that times -7/3 is 1, and still times 0 is 0. So we have it confirmed. We do have that z equals 0. That's cool. But let's keep it going. Now what we're gonna do is let's get rid of this one up here. That's gonna be easy because all I have to do is do row 3 plus row 1 to give us our new row 1. So let's write that out. So 0 plus 1 is 1, 0 plus 0 is 0, 1 plus -1 is 0. Okay, and of course 0 plus 0 is still 0. So, okay, once again, x is now confirmed to be 0. Y is probably going to be 0, but just to follow through with the process, let's multiply the bottom row by 1/3 and add it to the second row. So 1/3 times row 3 plus row 2 to give us a new row 2. So 1/3 times 0 plus 0 is 0. 1/3 times 0 plus 1 is 1. 1/3 times 1 is 1/3 plus -1/3 is 0. 1/3 times 0 plus 0 is 0. So there's your confirmation. X is 0, Y is 0, Z is 0. So in our nice coordinate format, we got 0, 0, 0. That's how you do it. Done. So for this one here, we have it written out in matrix format. Again, we're trying to get that nice identity matrix with the diagonals of 1. And then we got all zeros like so. And then we're going to perform operations to the rows to get it there. Okay, let's begin. So first, I already got a nice 1 here. That's what I want. I want to flip this maybe 2 to 0 next. So I'm going to multiply row 1 by -2, and then I'm going to add it to row 2 to get our new row 2. Let's check it out. So -2 times 1 is -2 plus 2 is 0. -2 times 1 is -2 plus -1 is -3. -2 times 1 is -2 plus 3 is 1. And then -2 times 0 is 0 plus 0 is 0. Cool. All right. Next, I'd love to flip this to 0. All I have to do is add negative row 1 plus row 3 to get our new row 3. So -1 plus 1 is 0. Nice. -1 plus 0 is -1. -1 plus -1 is -2. -0 plus 1 is still 1. All right, great. So now we got this first column set to how we like it. Let's flip this one to 1 by multiplying row 2 by negative 1/3. All right, let's check it out. So then we get negative 1/3 times 0 is 0. So then we get negative 1/3 times 0 is 0. Negative 1/3 times negative 3 is 1. Negative 1/3 times 1 is negative 1/3. And of course, negative 1/3 times 0 is still 0. Okay, cool. So now we got 1, 1, and now we need to flip this and this to 0. So we're going to make some more room down here. And the way I'm going to flip the top one is I'm going to simply add the third row to the first row. So then I'm going to be adding row 3 plus row 1 to get our new row 1. And let's write that out now. So 0 plus 1 is 1. Negative 1 plus 1 is 0. Negative 2 plus 1 is negative 1. And 1 plus 0 is 1. All right, cool. So now we got 1, 1, 0, 0, 0. Now we need to flip this to 1, or sorry, to 0. So I'm going to simply add, let's do a little arrow up here. We're going to add row 2 plus row 3 to get our new row 3. All right, let's write it out. So 0 plus 0 is 0. 1 plus negative 1 is 0. Negative 1/3 plus negative 2, that's negative 7/3, right? Because 1/3 plus 6/3, 7/3. And then 0 plus 1 is still 1. Cool. The next thing that would be great to do is to flip this to a 1, and that's pretty straightforward. Multiply it by its reciprocal, negative 3/7. So making some more room, we're going to say negative 3/7 times row 3. Let's write it out. So we got 3/7 times 0 is 0. Negative 3/7 times 0 is 0. Negative 3/7 times negative 7/3 is 1. Negative 3/7 times 1 is negative 3/7. So we have our first value. We have z is equal to negative 3/7, but let's keep going. Now I'd love to zero out this one. That's going to be pretty straightforward. We just do row 3 plus row 1 to give us our new row 1. Let's check it out now. 0 plus 1 is 1. 0 plus 0 is 0. 1 plus negative 1 is 0. That's beautiful. And then negative 3/7 plus 1, that's positive 4/7. So since we have a 1 and 0, 0, we know that 1x equals 4/7. So now we solve for x and for z. We need to solve for y, so we got to zero this out. The way I'm going to do it is I'm going to multiply the third row by 1/3, add it to the second row. Let's write it out. 1/3 times row 3 plus row 2 to give us a new row 2. Here we go. So 1/3 times 0 plus 0 is 0. 1/3 times 0 plus 1 is 1. 1/3 times 1 is 1/3. 1/3 plus negative 1/3 is 0. And then 1/3 times negative 3/7. Let's write it out. 1/3 times negative 3/7 cancels out to negative 1/7. Negative 1/7 plus 0 is negative 1/7. So there it is. Our x value is 4/7. Y is negative 1/7. And z is negative 3/7. And there's our solution done. All right, so for this one, we're going to start by putting it in that nice matrix format. But you'll notice, like, this is gnarly, right? These fractions and all this stuff is crazy. So I'm actually going to do something right off the bat to kind of make this a lot easier without all these crazy fractions. I'm going to multiply row 2 by 10, and I'm also going to multiply row 3 by 2, okay? Let's just get rid of all the fractions. So when I multiply this by 10, that becomes 2. 10 times negative 1/2 is negative 5. 10 times 3/5 is 6. And 10 times 1 is 10. Okay, down here, we got 2 times row 3, so we got negative 8. 2 times negative 3/2 is negative 3. 2 times negative 1 is negative 2. And 2 times negative 74 is negative 148. Cool. Okay, now let's start to make this work, right? I'd love to flip this to a 1 as my first step. So I'm going to multiply the top row by 1/6. Again, we're trying to get that nice diagonal of 1s and then 0s throughout, like so. All right, let's check it out. So normally what I would do is I'd probably try and flip this to a 1, but instead I'm seeing like something pretty cool here. I'm seeing that these are kind of matched up with these. So what I'm actually instead going to do is I'm going to flip these to 0 because I know I have to do that eventually. I'm going to hit row 2 with a negative, and I'm going to add it to row 1 to get a new row 1. So let's write that out. Negative 2 plus 6 is 4. Negative 5 plus negative 5 is 0. Negative 6 plus 6 is 0. Negative 10 plus 38 is 28. This is awesome. And then I'm going to multiply row 1 by 1/4 to flip that to a 1. So this is going to be just nice and straightforward. We don't have to do with too many fractions. So that's a nice little step. So we've got 1/4 times 4, which is 1. 1/4 times 0 is 0. 1/4 times 0 is 0. 1/4 times 28 is 7. And check it out. We got our first value. x is equal to 7. Awesome. Now we're going to make some more room, and I'd love to flip this one into a 0 next. So what I'm going to do is I'm going to multiply row 1 by -2, and I'm going to add it to row 2 to get a new row 2. Let's write it out. So -2 times row 1, that's -2 plus 2 is 0. That times 0 is 0 plus -5 is -5 times 0 is 0 plus 6 is 6. And the -2 times 7 is -14 plus 10 is -4. All right, cool. Then I'd love to flip this one. So I'm going to multiply row 1 by 8. I'm going to add it to row 3, and that's going to be our new row 3. Let's write it out. So 8 times 1 is 8 plus -8 is 0. 8 times 0 is 0 plus -3 is -3. 8 times 0 is 0 plus -2 is -2. 8 times 7 is 56 plus -148 is -92. All right, awesome. Next, I'd love to flip this to a 1 so I can multiply it by -1/5. Let's make some more room. So we got -1/5 times R2. Let's write it out. So 1/5 times 0 is 0. 1/5 times -5, or -1/5, I should say, times -5 is 1. -1/5 times 6 is -6/5. -1/5 times -4 is +4/5. All right, awesome. And then I'd love to flip this to a 0. So I'm going to multiply row 2 times +3, add it to row 3, and that's going to be our new row 3. Let's write it out. So we got 3 times 0 plus 0 is 0. 3 times 1 is 3 plus -3 is 0. 3 times -6/5, that's -18/5 plus -2, which is the same as -10/5. So that's going to be -28/5 down here. And then 3 times 4/5 is 12/5 plus -92, which is the same as -460/5. So -460 plus 12 is -448/5. Next, I think what would be nice is to flip this into a 1, and that's pretty easy. I could just multiply by the reciprocal of -28/5, which is -5/28. Let's make some more room, and we're going to multiply row 3 by -5/28. Let's write it out. So that times 0 is 0, that times 0 is 0, that times that is 1 because they're reciprocals. And then the last part, -5/28 times -448/5. Let's do that in a calculator. And when we multiply them together, look how nice that is. That is a nice 16. So we got 16 here, and that means z equals 16. All we got to do now is find our y. And we need to zero this out to do so. What I'm going to do is I'm going to multiply row 3 by -6/5, right? Turn that into +6/5, excuse me. And then we're going to add that to row 2 to get a new row 2. Let's write that out. So 6/5 times 0 is 0 plus 0 is 0. 6/5 times 0 is 0 plus 1 is 1. 6/5 times 1 is 6/5 plus -6/5 is 0. And then we do 6/5 times 16, which is 96/5, and then we're adding it to 4/5. And look at that. They have a nice common denominator. That's 100/5, which reduces to 20. So we got x is 7, y is 20, and z is 16. Let's write that out. So in our nice coordinate format, we got 7, 20, 16. That's how you do it. Done. So for this one, I can start to fill out the matrix as I've done in these other previous examples. But look, we got all these fractions. This is a nightmare, right? And I don't want to deal with that, but I can easily multiply all of these and clear the fractions, right? In this top one, if I multiply by the least common multiple of 3, 2, and 4, which is 12, I can clear those fractions. For this one, 2 and 4, the least common multiple is 4, so I multiply everything by 4. And for this one, I got 4 and 2, again, multiply by 4. So watch what happens. 12 times -1/3 is -4. 12 times -1/2 is -6. 12 times -1/4 is -3. 12 times 3/4 is 9. Much better. Then we got 4 times -1/2 is -2. Times -1/4 is -1. Times -1/2 is -2. And then times 2 is 8. And then we got here -1, -3, right? 4 times -1/2 is -2. And then again, 4 times -1/2 is -2. So much better. All right, now let's begin. Again, I love to start with this spot to turn it into a 1. But actually, I see a nice little opportunity here. I can quickly and easily flip this one to a 0. So I'm going to actually start with that. So I'm going to multiply row 3 just by a negative. I'm going to add it to row 2, and we're going to get a new row 2. So let's do that now. So we got +1 plus -2 is -1. +3 plus -1 is 2. And then positive 2 plus negative 2 is 0. And then we got positive 2 plus 8 is 10. So we flip that nice and easy. Now let's go ahead and multiply the top row by 1/4 negative. Okay, so when we do that, we're going to get this into a 1. So we got negative 1/4 times negative 4 is 1. Negative 1/4 times negative 6 is positive 3/2. Negative 1/4 times negative 3 is 3/4. And negative 1/4 times 9 is negative 9/4. Now this is great because I can start to flip these guys to 0 pretty easily by just adding negative row 2 to row 3. So I'm going to start with that, and that's going to give us a new row 3. Let's write it out. So we got negative 1 plus negative 1 is 0. Negative 2 plus negative 3 is negative 5. Negative 0 plus negative 2 stays negative 2. Negative 10 plus negative 2 is negative 12. Now to flip this one to 0, I'm going to add row 1 to row 2. Let's make some more room. So just row 1 as is plus row 2 to get a new row 2. Let's write it out now. So we got 1 plus negative 1 is 0. 3 halves plus 2, that would be 4 halves. So that'd be 7 halves. And then 3/4 plus 0 is 3/4. Negative 9/4 plus 10, which is the same as 40/4, right? Common denominator. Add those together, that becomes 31/4. Next, I'd love to flip this to a 1, and I can do that by just multiplying by 2/7. So we got 2/7 times row 2. Let's write it out. So we got that times 0 is 0. That times 7 halves is 1. Beautiful. And then that times 3/4. That's going to be 6/28, which reduces to 3/14. And then 2/7 times, let's write this out, 2/7 times 31/4, cancel into a 2, and we get 31/14. All right, so far these are messy fractions, but let's see how it goes. Now I'd love to flip these two into zeros, so let's multiply the second row by 5 and add it to the third row. So 5 times row 2 plus row 3 gives us a new row 3. Let's see what we get. So 5 times 0 is 0 plus 0 is 0. 5 times 1 is 5 plus negative 5 is 0. 5 times 3/14 is 15/14 plus negative 2, that's negative 28/14. 15 minus 28 is negative 13/14. And then we've got 5 times 31/14, that's 155/14. And then negative 12, if I put that over 14, 12 times 14, I believe is 168. So we got 155 minus 168, what is that, negative 13, right? So then we got negative 13/14. All right, that's pretty cool. And you know what? I'm going to take this opportunity to actually, instead of even flipping this to 0, which is normally my next move, I'm going to, look, I just multiply this by the reciprocal, negative 14/13, right? And that's going to flip that to 1. So I got negative 14/13 times R3. Let's write it out. So we got times 0 is 0, times 0 is 0, times its reciprocal is 1, and again times its reciprocal is 1. So guess what? We already know that Z is 1. Beautiful. All right, let's keep going. Now as we make more room, I am going to next flip this into 0, and I'm going to do that by multiplying row 3 by negative 3/14, right? That's going to turn that into negative 3/14, and then add it to row 2 to get a new row 2. Let's write it out. So negative 3/14 times 0 is 0 plus 0 is 0 times 0 is 0 plus 1 is 1 times 1 is negative 3/14 plus 3/14 is 0. And then times 1 again is negative 3/14, and that's being added to 31/14, which is 28/14, and that reduces to 2. So check it out. We now know that y is equal to 2. All we got to do is get x. We got to clear these out to 0. Let's do that now. So first I'm going to multiply row 2 by negative 3 halves, and I'm going to add it to, row 1, and we're going to get a new row 1. Let's write this out. So negative 3 halves times 0 is 0 plus 1 is 1 times 1 is negative 3 halves, so 3 halves is 0, just like we want, and then times 0 is 0 plus 3/4, that stays the same. And then negative 3 halves times 2 is actually negative 3 plus negative 9/4. Let's see, negative 9/4 plus negative 3, which is the same as 12/4. That gives us negative 21/4. Okay, we got one last step. We got to get rid of this. So I'm going to multiply this row 3 by negative 3/4 and add it. So let's do that down here. Negative 3/4 times row 3 plus row 1 gives us our new row 1. Let's write that out. So we got negative 3/4 times 0 is 0 plus 1 is 1. Negative 3/4 times 0 is 0 plus 0 is 0. Negative 3/4 times 1 is negative 3/4 plus 3/4 is 0. Beautiful. And then negative 3/4 times 1 is negative 3/4 plus negative 21/4 is negative 24/4, right? And then that simplifies to negative 6, which means our final answer, x, y, and z is negative 6, 2, 1. That's how you do it. Done. So for this one, I want to start by clearing all these fractions, right? These are going to be a nightmare. So what we're going to do is we're going to start by multiplying each equation by the least common denominator of these three, right? So 5, 8, and 2, that's going to be 40. So I'm going to multiply this entire equation by 40. This one, 5, 4, and 3, that's going to be 60. So I'm going to multiply that whole thing by 60. And then this one, 5, 8, and 2, again, that's going to be 40. All right, let's see what we get. So 40 times 4/5, that's 32. 40 times negative 7/8, that's negative 35. And then 40 times 1/2 is, of course, 20. And then we got 40 over here because it's 40 times 1. 60 times negative 4/5, let's see, divided by 5, that's 12 times 4 is negative 48. We got some big numbers here. 60 divided by 4/15 times 3 is negative 45. And then times 1/3 is 20. Ooh, times negative 8, that's a big number, negative 480. And then last but not least here, divided by 5 is 8 times 2, negative 16. Divided by 8 is 5 times 7 is negative 35. Half is 20 times negative 5 is negative 200. Okay, big numbers, let's go. I'm seeing something interesting here when you look at this and this, this and this, right? It's going to be pretty easy to knock those out because I do need both of these to go to 0. So you know what? My first step is going to be, though a lot of times I like to convert this first to a 1, I'm going to multiply row 3 times negative 1. I'm going to add it to row 1 to get a new row 1. So let's check that out. And again, remember our objective, we're trying to get 1, 1, 1, 0, 0, 0, 0, 0, 0, right? That nice identity in here, and then that will lead us to our answers. So when I do that, remembering, of course, that these two rows stay unchanged, we're going to have positive 16 plus 32 is 48. We have positive 35 plus negative 35 is 0. Negative 20 plus positive 20 is 0. And then positive 200 plus 40 is 240. All right, cool. And now it actually does seem really easy to flip this one into 1 by multiplying by 1/48, and since these are both 0, so I'm going to actually do that next. I'm going to multiply row 1 by the reciprocal of 48, which is 1/48. Let's write that out. So we got that times that is 1 times the zeros is still 0. And then 148 times 240, that's actually exactly 5. So guess what? We got our first answer, 1x equals 5. But anyways, we got to keep going. Next, I'd love to flip this and this to 0, so we're going to do that next. And I'm going to do that first by multiplying row 1 by positive 16, I should say, times row 1 added to row 3 to get a new row 3, right? So we're kind of going this way. Let's write that out. So 16 times 1 is 16 plus negative 16 is 0. 16 times 0 is 0 plus negative 35 is negative 35 times 0 is 0 plus 20 is 20. And then 16 times 5 is 80. 80 plus negative 200 is negative 120. All right, cool. Now let's flip this. So again, I'm going to multiply row 1. This I'm going to multiply it by 48. So 48 times row 1 plus row 2 gives us a new row 2. Let's write that out. So 48 times 1 plus negative 48 is 0. 48 times 0 is 0 plus negative 45. That stays the same. Same with this. Times 0 is 0 plus 20 is 20. And then 48 times 5 is 240. 240 plus negative 480 is negative 240. All right, now we got a lot of stuff, right? We got zeros here, we got zeros here. That's beautiful. I'd love to now flip this one into a 1. So making some more room, we're going to multiply row 2 by negative 1/45, right? The reciprocal of negative 45. So that times row 2. Let's write that out. So negative 1/45 times 0 is 0, times negative 45 is 1, and then times 20 is negative 20/45, which would be negative 4/9 when you simplify it. And then negative 1/45 times negative 240, that's going to be positive 240 over 45. We can simplify by dividing top and bottom by 5. That would be 48 over 9 divided by 3. That's 16 over 3. So we got positive 16 over 3. Next, I'd love to flip this to a 0. So I'm going to multiply row 2 by 35, right? Hit that one up to add to this to get to 0. So 35 times row 2 plus row 3 to get a new row 3. Let's write that out. So 35 times 0 is 0 plus 0 is 0. 35 times 1 is 35 plus negative 35 is 0. And then 35 times negative 4 ninths, let's write that out. That's 120 plus 20 is 140 over 9. So that's negative 140 over 9 plus 20, which is 180 over 9. So we add those together, we'll get just a 40 over 9. And then we got 35 times 16 thirds. Let's write that out. 35 times 16 is 560. So that's 560 over 3. And then we're adding it to negative 120, which is negative 360 over 3, right? Add those together and we get positive 200 thirds. All right, we're almost there. Let's move it down, make a little bit more room. Okay, next I'm going to hit this one. I'm going to convert that to a 1. So I'm going to multiply the reciprocal 9/40ths times row 3. Let's write it out. So we got that times 0 is 0. That times 0 is 0. That times 40 over 9 is 1. And then 9/40ths times 200 over 3. Let's cross simplify. That's 1 and that's 3. That's 1 and that's 5. 5 times 3 is 15. Boom, we now have our value for z. Z is 15. Okay, last but not least, we got to flip this to a 0. So I'm going to multiply row 3 by 4 ninths, and then I'm going to add it to row 2 to get a new row 2. Let's write it out. So 4 ninths times 0 is 0 plus 0 is 0. 4 ninths times 0 is 0 plus 1 is 1. 4 ninths times 1 is 4 ninths plus negative 4 ninths is 0. That's beautiful. And then 4 ninths times 15, right? That's going to be 60 over 9. And then we're adding it to, right, that's positive, right? Yep, 60 over 9. And then we're adding it to 16 thirds, which if I multiply top and bottom by 3, that's 48 over 9. So we add those together. That's 108 over 9. 9 goes into 108 12 times. So guess what? We got our x is 5, our y is 12, and our z is 15. Let's make a little bit more room and write it out in coordinate format. So we got 5, comma 12, comma 15. There's your solution. That's how you do it. Done. So for this one, I'd love to start by clearing these fractions because, you know, that's going to make it pretty messy. But we can do that by first multiplying by the least common denominator of 4, 4, and 2, which is 4. Same with this one of 2, 3, 4, and 12 is 12. And this one is all 3s, so just 3. Okay, so now as we put it into matrix format, 4 times negative 1/4, negative 1, times negative 5/4, negative 5, times 5 halves, that is 10, times negative 5 is negative 20. Here we have negative 6. 12 times 5 thirds, 12 divided by 3 is 4, times 5 is negative 20. Times 5/4 divided by 4 is 3, times 5 is 15, and then times 55/12 cancels out the denominator, 55. Last row, 3 times negative 1/3, negative 1. Same thing here, negative 1. Here is positive 1. 3 times 5/3 is 5. All right, there's our starting matrix. And the first thing I can do is immediately flip this to a 1, right? We want that 1, 1, 1, 0, 0, 0 formation, like so, right? So we're going to multiply row 1 by a negative. That's going to be pretty quick. Let's write that here. So we got 1, 5, negative 10, and 20. All right, next let's flip this to 0 and this to 0. First, let's do row 2. So I'm going to multiply row 1 by 6. I'm going to add it to row 2, and that's going to give us a new row 2. Let's write it out. So 6 times 1 is 6 plus negative 6 is 0. 6 times 5 is 30 plus negative 20 is 10. 6 times negative 10 is negative 60 plus 15 is negative 45. 6 times 20 is 120 plus 55 is 175. Cool. All right, now let's flip this one. This one's a little bit more straightforward, right? I'm just going to add row 1 to row 3 to get a new row 3. So like so, and let's write it out. 1 plus negative 1 is 0. 5 plus negative 1 is 4. Negative 10 plus 1 is negative 9. 20 plus 5 is 25. All right, great. So we got this column done. So next, actually, I'm going to get rid of this negative 45. The reason why is just because it looks nice and easy, right? I can multiply row 3 by negative 5, add it to row 2, and we can flip that easily to get a new row 2. Let's write that out. So negative 5 times 0 is 0 plus 0 is 0. Negative 5 times 4 is negative 20 plus 10 is negative 10. And then negative 5 times negative 9 is 45 plus negative 45 is 0. Negative 5 times negative 25 is actually negative 125 plus 75 is 50. Cool. Okay, now we can hit this one and we can flip that to a 1. So I'm going to multiply row 2 by negative 1/10. Let's write that out. So then we got 0, negative 1/10 times negative 10 is 1, negative 1/10 times 0 is 0, negative 1/10 times 50 is negative 5. And look at that, we got our first value. We know that y is negative 5. All right, let's keep it going. Next, I'm going to flip this one to 0 by multiplying row 2 by negative 5 and adding it to row 1 to get a new row 1. Let's write that out. So we got negative 5 times 0 is 0 plus 1 is 1. Negative 5 times 1 is negative 5 plus 5 is 0. Awesome. Negative 5 times 0 is 0 plus negative 10 is negative 10. And then we got negative 5 times negative 5, is 25 plus 20 is 45. All right, great. Next, I'm going to flip this to 0. So I'm going to multiply row 2 by negative 4 and add it to row 3 to get a new row 3. Let's write it out. Negative 4 times 0 is 0 plus 0 is 0. Negative 4 times 1 is negative 4 plus 4 is 0. Negative 4 times 0 is 0 plus negative 9 is negative 9. And then negative 4 times negative 5 is 20 plus 25 is 45. All right, cool. Next, I can easily flip this to 1, right? We need that to be a 1, so I can multiply by negative 1/9. So making some room here, we got negative 1/9 times row 3, and let's check it out. So times 0 and 0 is 0, of course, and then negative 1/9 times negative 9 is 1. Negative 1/9 times 45 is again negative 5. So it looks like at this point, y and z are negative 5. All right. Last but not least, we got to flip that to 0. So I'm going to multiply row 3 by 10, add it to row 1 to get a new row 1. Let's write that out. 10 times 0 is 0 plus 1 is 1. 10 times 0 is 0 plus 0 is 0. 10 times 1 is 10 plus negative 10 is 0. And 10 times negative 5 is negative 50 plus 45 is negative 5. Look at that, all negative 5s. So when we write this out, we got negative 5, negative 5, negative 5 for x, y, and z. That's how you do it. Done. So for this one, I'm going to start off by making these numbers a little bit easier. So I'm going to start by multiplying every single equation by 10. So let's write that out. So we got 1, negative 2, 3, right? Just basically moving the decimal over by 1, and then that's 20. We got 5, negative 1, 4, and that's going to be 80. And then here we have 7, negative 2, and 3, and that's going to be 80. All right, this is great. Now what I'm going to do is I'm going to start knocking these out. The good thing is I'm starting with the 1 here. So to knock this to 0, it's pretty simple. I just multiply row 1 by negative 5, and I add it to row 2 to get a new row 2. Let's write that out. So then we got negative 5 plus 5 is 0. Positive 10 plus negative 1 is 9. Negative 15 plus 4 is negative 11. And then we have negative 100 plus 80 is negative 20. All right, cool. Now let's flip this to 0. And we're going to do something similar. I'm going to take row 1 and I'm going to multiply it by negative 7, add it to row 3 to get a new row 3. Just a reminder, we're trying to get that nice diagonal of 1s with 0s kind of throughout in the other spot. So that's why we need to flip these two to 0. So then we got negative 7 plus 7 is 0. Positive 14 plus negative 2 is 12. And then negative 21 plus 3 is negative 18. And then we have negative 140 plus 80 is negative 60. All right, cool. So we got this column done. Now what we're going to do is we're going to quickly wipe out these two. And the reason why I spotted that is because that's going to be pretty easy. All I have to do is multiply 1/6 times row 3, add it to row 1, and we're going to get a new row 1. And we're going to write that out. Let me show you. So we got 1/6 times 0 is 0 plus 1 is 1. 1/6 times 12 is 2 plus negative 2 is 0. 1/6 times negative 18 is negative 3 plus 3 is 0. 1/6 of negative 60 is negative 10 plus 20 is 10. And look at that. We got our value for x. It has to be 10. All right, now let's make a little bit more room and let's flip this to 1 next. So I'm going to multiply row 2 by 1/9. Let's see what we get. So we got 0. 1/9 of 9 is 1. 1/9 of 11 is negative 11/9. 1/9 of negative 20 is negative 20 over 9. All right, cool. Now I'd love to knock this out. So I'm going to multiply row 2 by negative 12. Add it to row 3 to get a new row 3. So negative 12 times 0 is 0 plus 0 is 0 times 1 is negative 12 plus 12 is 0. times negative 11 over 9, that's 132 positive over 9, plus negative 18, which if you put it over 9, that's going to be 9 times 18, 90, 72, 162. So 132 minus 62 is negative 30 over 9. And then we've got negative 12 times this, which is 240 over 9, which is the same as 80 over 3. And then 80 over 3 plus negative 60, which if I multiply it by 3, that's negative 180 over 3. 80 minus 180 is negative 100 over 3. Cool. Now, this one I want to flip to 1, and that's going to be pretty easy because I just multiply by the reciprocal of that fraction, which is negative 9 over 30. I know I can reduce that to 3/10, but let's just leave it as is for now. So negative 9 over 30 times row 3. So then I get times 0 is 0, times 0 is 0, times its reciprocal is 1. And then we have negative 9 over 30 times negative 100 over 3. Of course, the negatives cancel out. That reduces to a 3. That goes to a 1. So then we have 300 over 30, but that simplifies to 10. All right, so look at that. X is 10 and Z is 10. Last but not least, we have to flip this. So what I'm going to do is I'm going to multiply that by positive 11 over 9. So 11 over 9 times row 3 plus row 2 gives us a new row 2. Let's write that out. So then we have 11 9 times 0 plus 0 is 0. 11 9 times 0 plus 1 is 1. 11 9 times 1 is 11 ninths plus negative 11 ninths is 0. Then we have 11 ninths times 10, which is 110 over 9. 110 over 9 minus 20 over 9 is 90 over 9. And guess what? That simplifies to 10. So that means every value x, y, and z is 10, 10, 10. So in the right format, we got 10, comma 10, comma 10. That's how you do it. Boom, done. So for this one, we're going to start by getting these decimals away to some degree, right? I could multiply everything by 100 and that would move everything over, but I think just multiplying everything by 10 is good enough. So we're going to write that out in matrix format next. Now again, this is arbitrary, right? I could have multiplied by 100. I could have multiplied by 1,000. I'm just doing something to make it a little bit easier to calculate. So 10 I think is good. It makes the numbers much easier to look at. Okay, next we're going to target this guy. I want to get rid of that. So what am I going to do? I'm going to multiply row 1 by negative 21 over 11, and I'm going to add it to row 2 to get a new row 2. Let's write that out. 21 over 11 times 11 is negative 21. It's negative, of course. And then negative 21 plus negative 21 is 0. Negative 21 over 11 times 7 is negative 147 over 11 plus 5, which is 55 over 11, which is going to give me negative 92 over 11. And then negative 21 over 11 times negative 31, that's 651 over 11. And then we're adding to negative 16. 16 times 11 is negative 176, so it's negative 176 over 11. 651 minus 176 is 475 over 11. And then we're going to do this times this plus this in Desmos. And we get 32.872 repeating. So we got 32.872 and the 72 repeats. Okay, I know we don't usually like to have repeating decimals in this, but we're going to have to use a calculator for a lot of these calculations just because look at how crazy all these numbers are. All right, cool. Next, I'd love to get rid of this. So I'm going to multiply the top row by negative 5/11 and add it to row 3. So we got negative 5/11 times row 1 plus row 3 gives us our new row 3. Okay, here we go. Negative 5/11 times 11 is negative 5 plus 5 is 0. Negative 5/11 times 7 is negative 35 over 11 plus 4, which is 44 over 11, which gives us a nice 9 over 11. Negative 5/11 times negative 31 is 155, right? 155 positive over 11. And then we're going to add that to negative 5, which is minus 55 over 11, which gives us 100 over 11. And then we're going to do the last one in the calculator. Negative 5/11 times this plus negative 0.7. And we get 7.4, and then it's 36 repeating. So we get 7.436, and that part repeats. Now just to simplify these, so we got these gnarly fractions, but we already got the zeros in those spots, which is nice. So I can multiply the second row and the third row by 11, right? And that's just going to clear out these fractions, make the numbers a little bit nicer. So we got 11 times 0 is 0. 11 times negative 92 over 11 is negative 92. This one becomes just 475. Down here we get 0, we get 9, and we get 100, right? Clearing out that denominator. And then multiplying this and this by 11, we're going to do that in Desmos. So this one gives us exactly 81.8. So there you go. And then the next one, and we get exactly 361.6. 361.6. That's nice. No more repeating decimals. All right, great. Now we can knock this one out by multiplying this row by 9 over, right? 9 over 92, because that's going to turn that into -9, and then we can add it to 9 and it will zero out. So that times row 2 plus row 3 gives us our new row 3. Let's write it out. So 9 over 92 times 0 is 0 plus 0 is 0 times this is -9 plus 9 is 0. Great. And then this times 475 plus 100, let's do that in Desmos. So 9 times 475 is 4275. So that means we got 4275 over 92 plus 100, which is the same as 9200 over 92. And we're going to keep this as a fraction because it's like a gnarly decimal. So this becomes 13,475, right, over 92. And then we got 9 over 92 times this plus this. And we get this crazy decimal. Now, it's going to be a really messy fraction. So we're going to just write it as, let's say 117.2, but remembering that it actually equals this. And we're going to keep this up here for further calculations. But right now, let's write it in as 117.2 for this sake. Now I can straight up solve for z by multiplying by the reciprocal of this. So I'm going to take row 3 and I'm going to multiply it by 92 over this thing. 1, 3, 4, 7, 5. All right, let's write it out. So then times 0 is 0, times 0 is 0, and then times that, since the reciprocals is just 1, and then we're going to have to do this times that, but the real number in Desmos, and we're going to do that in Desmos. And here we go, we get this nice even decimal, 0.8, or as a fraction would be 4/5. Okay, check it out, we got our answer for z, now we can keep going. Next, what I can do now that we've got this is I can zero out this and this pretty easily. So what I'm going to do is first to zero out this one, I'm going to multiply row 3 by -475, and I'm going to add it to row 2 to get our new row 2. So let's write that out now. All right, so -475 times 0 is 0 plus 0 is 0. -475 times 0 is 0 plus -92 is still -92. Then we got -475 times 1 is -475 plus 475 is 0. Beautiful. Then we got that times this fraction plus this. I'm going to do that in Desmos. And we add it together and we get this nice -18.4. So -18.4. This is great because now I can easily flip this to a 1 and solve for y, and I can do that by multiplying by the reciprocal of this, which is -1 over 92. All right, so let's do that. I know we said we were gonna flip this, but this is just too good. Let's get that next so we can solve for y. So then we multiply -1 over 92 times row 2, so that would be times 0 is 0, times that is 1, that's beautiful, times 0 is 0, and then this times this, let's do it in Desmos. And look at this, we get this nice, awesome number 0.2, but as a fraction to keep in line with this, we'll write it as 1/5. That's how they have it in the answers in the back. Okay, now let's get rid of this -31. I'm going to multiply 31 times row 3, add it to row 1. That's our new row 1. Let's write it out. So 31 times 0 is 0, plus that is 11, times 0 is 0, plus 7 is 7, times that is 31, plus -31 is 0. And then 31 times 4/5 plus -17.9. Let's do that in Desmos. And we get this nice 6.9. Let's write that out. Next, we're going to flip this to 0. So I'm going to multiply row 2 by -7 and add it to row 1. Let's write that out now. So -7 times row 2 plus row 1 to give us a new row 1. So -7 times 0 plus 11 is 11. -7 times 1 is -7 plus 7 is 0. Beautiful. And then that times 0 is 0 plus 0 is 0. And then -7 times 1/5 is -7/5 plus that 6.9. Let's do that in Desmos. And we get 5.5. So this is 5.5. Last but not least, we got one step left, right? Multiply the reciprocal of that 1/11 times row 1. Let's write that out. So 1/11 times 11 is 1, times 0 is 0, times 0 is 0, and then times 5.5. It's like dividing by 11, which is going to be 5.5 over 11, and what you'll notice is that is simply half, right? 5.5 is half of 11, so that's a half. And there you go. Finally, putting it in coordinate format, it's going to be x is 1/2, y is 1/5, and z is 4/5. That's how you do it. Done. So for this one right off the bat, we're going to start by multiplying every equation by 10. It's just going to make the numbers easier. I could multiply by 100, but I think 10 will be great. So let's write that out in matrix format. So we got 1, 2, 3, and 3.7, right? Basically moving the decimal over once. Then we got 1, -2, -3, and then that's -2.7. And then we got 5, 1, -3. Oh, sorry, that's a -1. 5, -1, -3, and -0.3. All right, now we're in a great spot. Let's start to work our way through. I see a 1 here. That's what we want. And then let's go ahead. So even though I have a 1 here, which is terrific, I see a really nice opportunity to zero out both of these guys simply by adding row 2 to row 1 to get a new row 1. So I'm going to write that out next. And again, remember our objective is to get that nice diagonal of 1s and then 0s like so. Okay, so if I do that, I get 1 plus 1 is 2, -2 plus 2 is 0, -3 plus 3 is 0, and -2.7 plus 3.7 is 1. So that's pretty nice. And then if I want to take this back to 1, I can just multiply this by 1/2. So we'll say 1/2 times row 1. Let's write that out here. So we got 1/2 of 2 is 1, 1/2 of 0 is 0, and then 1/2 of 1 is 1/2. And guess what? We got our x value. X is 1/2. Great. Okay. Now let's flip this to 0 next. So I'm going to multiply row 1 by a negative, simply add it to row 2 to get our new row 2. Let's write that out. So we got -1 plus 1 is 0, -0 plus -2 is just -2, right? Negative times 0 is still 0, so we got -3. And then -1/2 plus -2.7, that's like -0.5 plus -2.7, so we'll keep that in decimal form, -3.2. All right, now let's zero this one out. So I'm going to multiply row 1 by -5 and add it to row 3 to get a new row 3. Let's write it out. So -5 times 1 plus 5 is 0. -5 times 0 is 0. So -1 stays. So does the -3. And then -5 times 1/2, that's -2.5 plus -0.3 is -2.8. Cool. Next, I see that I can easily zero this out by multiplying row 2 by -1/2 and adding it to row 3 to get a new row 3. Let's write that out. So -1/2 times 0 is 0 plus 0 is 0. -1/2 times -2 is 1 plus -1 is 0. -1/2 times -3 is 1.5 plus -3 is going to be -1.5. And then half of -3.2, that's positive 1.6. Plus -2.8 is -1.2. Cool. Next, I see a really nice, easy layup is to get rid of this. I can do that by multiplying -2 against row 3, adding that to row 2 to get a new row 2. Check it out. So then -2 times 0 is 0 plus 0 is 0. -2 times 0 is 0 plus -2 is -2. -2 times -1.5 is 3 plus -3 is 0. -2 times -1.2 is positive 2.4. 2.4 plus -3.2 is -0.8. Okay, now let's flip this to a positive 1. So I'm going to multiply -1/2 times row 2. Let's write that out. So we got 0, -1/2 times that is 1. We got 0, -1/2 times that is positive 0.4, which can be represented as 2/5. All right, last thing to flip is this. And if you remember, -1.5 is really -3/2. So I'm going to multiply the last row by the reciprocal of that, which is -2/3. So -2/3 times row 3. Let's write it out. So -2/3 times that is 0, times that one is also 0. And then -2/3 times -1.5, it's 1 because they're reciprocals. And then let's write this one out, -2/3. And then -1.2 is the same as 1 1/5 or 6/5. So it's -6/5 like this. And as we multiply, cross simplify, that's 1, that's 2. So it becomes, and the negatives cancel out, it becomes 4/5. So we got 4/5. So there's our answer. Our x is 1/2, our y is 2/5, and our z is 4/5. And that's how you do it. Boom, done. So for this one, we're going to start by multiplying everything by 10 just to make the numbers a little bit nicer. So let's write that out. So we got 5, 2, -3, and 10. Then we got 4, -6, 7, and 8. And then here we got 3, -1, -9, and 6. First things first, I'm going to flip this to a 1. So I'm going to multiply the first row by 1/5 And we're going to write that out. So we got 1/5 of 5 is 1. 1/5 of 2 is 2/5. 1/5 of 3 is -3/5. 1/5 of 10 is 2. All right, cool. Now I'm going to use this 1 to zero out this one. So I'm going to multiply row 1 by -4 and add it to row 2, and we'll get a new row 2. Let's write that out. And actually, I'm going to rewrite this in decimal format. I think for the time being, it's just going to be easier to do the calculation. So that's going to be 0.4, -0.6, and then this is still 2. Okay, so -4 times row 1. So -4 times 1 is -4, plus 4 is 0. -4 times 0.4 is -1.6. Plus -6 is -7.6. -4 times -0.6 is 2.4 plus 7 is 9.4. So it's just a little easier to do the calculations. -4 times 2 is -8 plus 8. Ooh, look at that. We flipped it to 0. Interesting. Okay. Now let's flip this to 0. We're going to multiply row 1 by -3. Add it to row 3 to get a new row 3. Let's write that out. So we have -3 plus 3 is 0. -3 times that is -1.2 plus -1 is -2.2. -3 times -0.6 is 1.8. Plus -9 is -7.2, and then -3 times 2 is -6, plus 6 is 0. Interesting. So those two have zeroed out. What I'm going to do next is I'm going to flip this one to 1, and I'm going to do that by multiplying by the basically 1 over -7.6. So -1 over 7.6 times row 2. Let's write that out, and we'll use the calculator a little bit if we need to. So we got that times 0 is 0. That times -7.6 is 1. This times 9.4, let's do it in Desmos. So this gives us a pretty crazy decimal. I'm going to actually keep it as a fraction. So it would be 9.4 over 7.6, 94 over 76, divide by 2, simplify 47 over 38. So -47 over 38. And then of course, this times 0 is still 0. Cool. Next, I'll go ahead and zero this one out. I'm going to multiply row 2, because we got that nice 1 there, by -0.4, and I'm going to add it to row 1 to get a new row 1. Let's write that out. So we got -0.4 times 0 is 0, plus 1 is 1, times that is -0.4, plus 0.4 is 0. Beautiful. And then this times this fraction plus this, let's do that in Desmos. So we get a pretty crazy decimal, so I'm going to keep it as an approximation in the table, but just kind of keep this full value here. We'll come back to it. So we got approximately -1.09. And by the way, I had 30 written there. I realized it should have been 38. That was just wrote it down wrong. And then this time 0 is 0 plus 2 is 2. Okay, so that stays as is. Now let's wipe this one out. I can multiply again row 2 times by positive 2.2 and add it to row 3. So we got 2.2 times 0 is 0 plus 0 is 0 times 1 is 2.2 plus that is 0. Beautiful. And then 2.2 times this fraction plus this, let's do that in Desmos. And we get another crazy decimal, and we're going to just approximate -4.48 for now. And then, of course, times 0 is 0 plus 0 is 0. Great. Now, you can pretty quickly see that this one, that z has to be 0, and I'm going to show you why. Because the last step to flip this to a 1 is I just multiply by its reciprocal. Now, we can even say approximately that reciprocal is approximately -4.48. But I don't even have to plug it into Desmos. This is pretty straightforward because any number times its reciprocal is 1, and then everything else is a 0. So we're just going to get 0, 0. That times its reciprocal is 1, and then times 0 is 0. So look, we now know that z has to be 0. Okay, now what we got to do is flip these last two over, and this is actually going to be pretty simple too, because what I'm going to be doing is I'm going to be multiplying row 3 in either case by the opposite of this, meaning positive 47 over 38, and then the opposite of this, which is, whatever, positive 1.09, that's approximation, but we're going to multiply it by both of those, and then we're going to add row 3. And the thing is, everything else in row 3 is 0. So it doesn't change anything but these. And since we're deliberately flipping these to 0, I don't even have to write it out, but I'll write them out anyways. It would be 47 over 38 times row 3 plus row 2 is going to be a new row 2. And we've got, let's see, positive 1 over 1.09. Again, that's an approximation. Times row 3 plus row 1 gives us a new row 1. But we can do both steps in one full go because we know in both cases it's going to just zero out these guys, and then everything else stays the same. And there we go. We get our final answer. X is 2, Y is 0, Z is 0. So we got 2, 0, 0. That's how you do it. Done. All right, so for this one, I'm going to start out by multiplying everything by 10 just to move the decimal over once, make the numbers a little easier. So we're going to start with that. So here I got 10 times 0.8 is 8, then I got 8, then I got 8, and then here would become 24. This would become 3, -5, 2, and then 10 times 0 is 0. Last row, we got 1, 2, 3, and 6. Okay, so these are some pretty nice numbers. Now, right off the bat, I see something interesting in row 1, right? We got 8, 8, 8, and 24. I do eventually need to flip this to a 1, so why not start with that? I'm going to just multiply this entire row by 1/8, so let's write that out here. So we got 1/8 times 8 is 1 for all of these. 1/8 times 24 is 3. Great. Okay, next, let's see. I want to work on flipping this and this to 0. Let's first flip this to 0, so I'm going to multiply row 1 by -3, and we're going to add that to row 2 to get a new row 2. Let's write that out. So -3 times 1 is -3 plus 3 is 0 times 1 is -3 plus -5 is -8. Here we have -3 plus 2 is -1, and then we have -9 plus 0 is -9. Cool. Now let's flip this to 0. That's even easier. Negative times row 1 plus row 3 is going to give us that new row 3. Let's write it out. So we got -1 plus 1 is 0. -1 plus 2 is 1. -1 plus 3 is 2. -3 plus 6 is 3. Next, I'm going to flip this to 0, and to do that, I'm going to multiply row 3 by -1, add it to row 1 to get a new row 1. Let's write that out. So we got 0 plus 1 is 1, -1 plus 1 is 0, -2 plus 1 is -1, and -3 plus 3 is 0. Cool. Next, I want to flip this one to 0, but before I do that, I'm actually going to flip this to 1. And the reason why is because once this is 1, it's going to be really easy to 0 that out. So we got -1/8 times row 2 to get a new row 2, so let's write that out. So -1/8 times 0 is 0, -1/8 times -8 is 1. Beautiful. -1/8 times -1 is +1/8. -1/8 times -9 is 9/8. All right, great. And now I can knock this one to a 0 by multiplying row 2 by -1, adding it to row 3. So we got negative row 2 plus row 3 gives us a new row 3. Let's write it out. So -0 plus 0 is 0. -1 plus 1 is 0. Awesome. And then -1/8 plus 2 becomes 1 7/8, or I'll say 15/8. And then we got -9/8 plus 3, which is the same as 24/8. So 24 minus 9 is 15. So this would be 15/8. Okay, well, look at this. We got a nice little opportunity here. I can multiply row 3 by the reciprocal of that. That happens to also be the reciprocal of that. So we're going to do 8/15 times row 3. Let's write it out. So we got 8/15 times 0 is 0 times 0 is 0 times the reciprocal is 1. And that one is also 1. So look at this. We got our first answer. Z is 1. Okay, very cool. Now we just need to flip this and this to 0. The easy way to flip this one first is I'm just going to add straight up row 3 as it is to row 1, because that's going to 0 that out. So row 3 plus row 1 to give a new row 1. Here we go. So we got 0 plus 1 is 1. 0 plus 0 is 0. 1 plus -1 is 0. And then 1 plus 0 is 1. Well, look at this. Now we got another value. We know that x is 1. So we know that x is 1. We know that z is 1. We just got to figure out what y is. And, so we have to flip this to 0. So all I'm going to do is multiply row 3 by -1/8, right? And we're going to add it to row 2 to get a new row 2. Let's write that out. So we got -1/8 times 0 is 0 plus 0 is 0 times 0 is 0 plus 1 is 1 times 1 is -1/8 plus 1/8 is 0. And then times 1 is -1/8 plus 9/8 becomes 8/8, which is again 1. So that means x, y, and z are all 1. So in the right format, we got 1, 1, 1. That's how you do it. Done. So for 47 in the extension section, it doesn't say exactly how to solve these. So I guess we can use Gaussian elimination. We could use just regular elimination and our kind of like typical systems of equations like we did earlier. I'm going to go back to the systems. We've done a bunch of Gaussian exercises. So let's do that. And the first thing I'm going to do is, again, I want to clear these fractions. So I'm going to multiply equation 1, 2, and 3 all by 2. So the first one's going to be 10x minus 6y, and then times 2 is going to cancel out that denominator. But again, remember that negative is going to distribute. So we got -z minus 1 equal to 1. Then over here, we're going to have 12x plus y minus 9. Again, the 2 is going to cancel that out, right? Just so you know, we're multiplying everything by 2. And then that's going to be plus 4z is equal to negative 6. Last one, that 2 is going to cancel out with that. So we got x plus 8 minus 8y plus 2z is equal to 8. Just to simplify a little bit further, we're going to combine like terms, get rid of the constants. So the top one, it's going to be 10x minus 6y minus z. Adding 1 to both sides equals 2. Here we got 12x plus y plus 4z. And then I'm going to add 9 to the negative 6. That's going to be 3. And then here we're going to subtract 8 from both sides. That's just going to cancel it out. So then we have x minus 8y plus 2z is equal to 0. Cool. Now what I'm going to do is I'm going to group these two together and I'm going to group these two together. I'm going to choose a variable to get rid of. I think the easiest one to get rid of in both cases is z, right? We got a negative z, 4z, and 2z. Okay, so let's first take the top two. And to wipe out the z's, I'm going to multiply the top one by 4. So now I have 40x minus 24y minus 4z is equal to 8. Bottom one I'm going to keep the same. Now we're going to add these together, canceling this out. And then we got 52x minus 23y, right? Negative 24 plus 1 is negative 23 is equal to 11. And now we got an xy equation. Now let's take these two and we're going to match them up. And to do that, to match up the z's, I'm going to multiply the bottom by negative 2 again. So then when we add them together, they're going to cancel out. So I'll write them down here. We got negative 2x plus 16y minus 4z equals 0, right? Multiplied everything by negative 2. That one I'm going to keep the same. Now we add these together. Those will cancel out, and we get 10x plus 17y equal 3. Great. So now we have our two equations. Let's write them right on top of each other. And using our typical elimination, we're going to match up one of the variables. Now, these are going to be unpleasant fractions, but we're going to do what we got to do. So, for example, if I multiply this one, let's say we want to cross out the y's because they're already opposites. If I multiply by the reciprocal, or like 23 over 17, right? What that's going to do is it's going to turn that into a 23. So that's going to be great. So just moving down to give us a little bit more room, we got the top one's the same, and the bottom one becomes 230 over 17x plus 23y is equal to 69 over 17. Now when we add these together, those cancel out. And then 52 plus 230 over 17. If I write 52 as a fraction over 17, it's 884 over 17. So that plus 230 is 1114, right? 1114 over 17x. Those cancel out equals, and by the way, 11 becomes 187 over 17. So that equals this plus this, 187 plus 69. That's 256 over 17. Yikes. Okay, and then last but not least, to solve for x, we're going to multiply by the reciprocal of this, which is 17 over 1114. Those are going to cancel out. So there's my x. 256 over 1114, which can be simplified by dividing both by 2. So x equals 128 over 557. Now to solve for y, I'm just going to take one of these equations with just x and y. How about this one right here? It's just random, and we're going to plug this in for x. So I got 52 times 128 over 557. Man, these are just such bad numbers, but it is what it is. We got to do it. Minus 23y is equal to 11, and then we got to isolate. 52 times 128 is 6656 over 557 minus 23y equals 11. And then we have to subtract both sides by this thing. To make common denominators, right, 11 times 557 is, I'm using calculator, of course, is 6127. So just so it's a little easier, 6127. So when I'm minusing that, I can just minus the numerator, 6127 minus 6656. That's negative 529 over 557. Okay, last but not least, we're going to divide by negative 23, which is basically multiplying by 1 over negative 23. And this just so happens to go in exactly into 529 23 times. So 23 squared is 529. So that's kind of cool because the negatives cancel out and that just turns into a 23. So now I know that y is equal to 23 over 557. All right. So far we have x, we have y. Now we just have to figure out z. And to do that, we're going to have to take one of these equations with all three values in it and solve for the remaining z. I'm going to take this one with the 0. It's just sort of, again, arbitrary, but that is it. The equation is negative 2x plus 16y minus 4z is equal to 0. Just making a little room. Now we're going to plug and chug. So we got negative 2 times 128 over 557, plugging that x in for x. Then we got plus 16 times 23 over 557. And then we've got, what was it? Minus 4z is equal to 0. Okay, just making a little bit more room because these numbers are so crazy. So negative 2 times that is negative 256 over 557. 16 times 23, that is 368 over 557. And then, you know what? I'm just going to add 4z to the other side just to isolate z. Okay. Now we got negative 256 plus 368. That is 112, right? 112 over 557 equals 4z. And then we're going to divide by both sides by 4, which is basically dividing 112 by 4. And that is 28 over 557. So now just moving back up a little bit so we can see the values of x, y, and z. Finally, I'm going to write this in coordinate format. So we got 128 over 557, y is 23 over 557, and z is 28 over 557. All right, there you go. That's how you do it. Done. All right, so these ones, it doesn't specify exactly how to solve it. So I'm going to actually just use typical kind of like elimination, substitution, etc. So what I'm going to do is I'm going to start by clearing all these fractions, right? This top one, I want to multiply by the LCM of 6, 2, and 3, which is 6. This one, the LCM of 4, 2, and 2, which is 4. And this one, we just got a denominator of 2, so 2. Let's rewrite it. The top equation becomes x minus 3 plus 6. Divided by 2 is 3, so then we distribute the 3 to the y plus 2, so it's 3y plus 6. And then 6 divided by 3 is 2, but then it's a negative 2 because of that minus. So then that negative 2 distributes, so then we have minus 2z plus 6, right? Negative 2 times negative 3 is positive 6, equals 6 times 2, which is 12. This one becomes x plus 2. And then 4 divided by 2 is 2 times y minus 5 is 2y minus 10. And then 4 divided by 2 is 2 times z plus 4 is 2z plus 8 is equal to 4 times 1, which is 4. Last one, the 2's are going to clear out those fractions. So we got x plus 6. And then that negative is going to distribute to both of those. So it's minus y plus 3. And then it's plus 2z plus 2 equals 18. Okay, now I want to simplify these equations a little bit. We're going to make some room here. This is going to take a lot of steps. So let's combine like terms kind of. We're going to do it as efficiently as possible. So the negative 3 plus 6 is 3 plus 6 is 9. Subtracting 9 from both sides, we get 3 on the right-hand side. And then on the left-hand side, we just have x plus 3y minus 2z. There we get a nice equation. Then this one we got 2 plus negative 8, negative 10 is negative 8 plus 8, that cancels out. So all those numbers cancel out. So we just have x plus 2y plus 2z is equal to 4. Last but not least, 6 plus 3 is 9 plus 2 is 11. Subtracting 11 from both sides, we get 18 minus 11 is 7. So over here, then we have the remaining x minus y plus 2z. Okay, great. Now I see a really easy opportunity to do one of two things. I can either eliminate x's, right? Or I can eliminate the z's. I'm gonna actually opt to eliminate the z's, okay? So I'm gonna group these two together and I'm gonna group these two together. So to eliminate the z's in the top two, it's really easy. I just add the equations as is, right? I don't have to change anything. So I'm not even gonna rewrite it. X plus x is 2x, 3y plus 2y is 5y. The z's are going to cancel out, and then we got 3 plus 4 is 7. Now for the second two, I'm going to negate the top one. So I'm just going to, I just did it arbitrarily. So it's negative x minus 2y minus 2z equals negative 4. Then I'm going to add it together. Z's are going to cancel out. Well, the x's happen to cancel out. I wasn't expecting that. And then we just get negative 3y, right? Negative y plus negative 2y is negative 3y equals 7 plus negative 4, which is 3. Well, look at this. We already got our solution for y. Y is negative 1. This is pretty nice because I can take that, plug it in here. 2x minus 5, right? 5 times negative 1 is negative 5 equals 7. Now to isolate, I add 5 to both sides. 2x equals 12, divide by 2, and x equals 6. Beautiful. So now we have x and y. Now we got to get z, so let's choose one of these equations and plug it in. Let's choose this one. This one looks pretty easy. So we got 6 for x minus negative 1 for y plus 2z is equal to 7. That's double negative, becomes a plus. 6 plus 1 is 7. So 7 plus 2z is equal to 7. Subtract 7 from both sides, that's 0. 2z equals 0, which means z equals 0, which means our final solution is 6, comma, negative 1, comma, 0. And that is how you do it. Done. 3 even numbers sum up to 108. The smaller is half the larger, and the middle is 3/4 of the larger. What are the 3 numbers? So let's just arbitrarily say small, medium, and large. And I'm going to just assign x, y, and z. And it's nice to have these labels because it'll help us with the equations. So it says the smaller is half the large. And then it says the middle is 3/4 of the large. And last but not least, the 3 together add up to 108. So now I got my triple system. Okay. Now the first thing I'm going to do is I want to clear these fractions out. So I'm going to multiply the top one by 2, the bottom one by 4. So now we have 2x is equal to z, and then we got 4y is equal to 3z. So what I'm going to do next is I'm going to combine this equation with this equation to eliminate the y's. And the reason why is because I already have an equation with just x and z, so I'd like another one with just x and z. So if I've got this one, 4y is equal to 3z, I can also write that if I subtract 3z from both sides, right, then I'd have 0 over here. So 4y minus 3z equals 0, and there is no x. Now what I can do is I can combine these in the following way. If I multiply the top one by negative 4, I'm going to get negative 4x minus 4y minus 4z is equal to negative 432. And then as we add these together, the y's will cancel out. So then I have negative 4x minus 7z is equal to negative 432. Okay, now I have this equation and this equation, and check it out. I can do a little substitution. If I know z is equal to 2x, I can plug and chug. So negative 4x minus 7 times 2x is equal to negative 432. So negative 7 times 2x is negative 14x, combined with negative 8x is negative 18x is equal to negative 432. And then we divide both sides by negative 18. And that's a nice even 24. So x is equal to 24. So that's the small one. And then I can pretty easily find the medium and the large because I got these nice equations, right? If x is 24 and it's half of the large, well, the large must be 48. If y is 3/4 of the large, 3/4 of 48 is 36. So my final answer is 24, 36, 48, like so. That's how you do it. Done. At a family reunion, there were only blood relatives consisting of children, parents, and grandparents. Let's just quickly get our nice variables for that. So we'll say x, y, and z. There were 400 people total. That's our first relationship. X plus y plus z is equal to 400. There were twice as many parents as grandparents. So that means whatever the parents are, to get to have an equal number of grandparents, I'd have to multiply it by 2, right? Because they're saying whatever there's twice as many parents as grandparents. And then it says 50 more children than parents. So if I've got my number of children and I take my parents, I would add 50 to that and I get the number of children. Guess what? Now we got our triple system, and let's see what we can do. So what I'm noticing right here is I've got this really nice equation here with y and z. So if I can similarly kind of combine this with this equation to remove the x's, I can have a second equation with just y and z, and we can take it from there. So what I'm going to do is just a straight up substitution. I can plug in y plus 50 in for x. So then it would be y plus 50 plus y plus z is equal to 400. Combine like terms, we got 2y minus 50 from both sides is going to be 350, and then still plus z. So there we go, 2y plus z is equal to 350. Now we can do a little substitution. Sub in 2z for y. So 2 times 2z is 4z. So we got 4z plus z equals 350. That's 5z equals 350. And divide both sides by 5, z equals 70. Beautiful. So we know the number of grandparents. Now to get the number of, let's say, parents, 70 in for z. 2 times 70 is 140. So the number of parents is 140. Last but not least, we need the number of children. I can plug that into this equation. 140 plus 50 is 190. So that means we have 70 grandparents, 140 parents, and 190 children. That's how you do it. Done. Your roommate, Shani, offered to buy groceries for you and your other roommate. The total bill was $82. And she forgot to save the individual receipts, but remember that your groceries were 5 cents cheaper than half of her groceries and that your other roommates were $2.10 more than your groceries. How much was each of your share? Okay, so first we're going to set variables for each. You are going to be X. This is all arbitrary. Shani will be Y, and the other roommate will be Z. So the total, meaning X plus Y plus Z, is 82. And then she remembered that your groceries were 5 cents cheaper than half of Shani's groceries. So half of Shani's, 1/2 of Y, minus 0.05, because it's yours are 5 cents cheaper than half, 5 cents less than half. There's that one equation. And that your other roommate's groceries, Z, were, notice this to be verb, were, is always equal. Your other roommate's groceries were $2.10 more than your groceries, which is X. All right, now we got our triple system. So what I'm gonna do right off the bat is we can do a little substitution. Check it out. Right now I know that this equation is in terms of just Z and X. Well, if I take this, if I can isolate Y here and then substitute whatever that is in for this top equation, I'll get two equations with just X and Z. So first, what I'm gonna do is let me multiply this equation by 2 just to get rid of that fraction. So now we have 2x is equal to y minus 0.1. Then I'm going to add 0.1 to both sides. 2x plus 0.1 is equal to y. Now what I can do is I can plug this in to this top equation. So let's write that out now. We have x plus 2x plus 0.1 instead of y, right? Subbing that in, plus z equals 82. Then let's combine like terms. That's going to be 3x plus z is equal to, and then I'm going to subtract 0.1 from both sides, and that's going to be 81.9. Okay, so now we have this equation. We also have z is equal to 210 plus x. Well, that's prime for substitution, right? Now I can plug this in for z, and we can solve for x. So just to make a little room, now we got 3x plus 2.1 plus x again is equal to 81.9. Combined like terms, 3x plus x is 4x, simultaneously subtracting both sides by 2.1, which is 79.8. Divide both sides by 4, and that's going to be 19.95. So that means your groceries are 19.95. Now we can take this value and I can plug it straight back into this equation to get the other roommate's cost. So 19.95 literally plus 210, that's going to be 22.05. So z equals 22.05. That's the other roommate up here. And then now to solve for y, if I know x, I can plug it into this equation. So 2 times 19.95, that is 38, 39.90, I believe. So we got 39.9 plus 0.1 equals y. 39.9 plus 0.1 is an even $40. And that's for Shani. So here's our final answer. Yours was 19.95, Shani's was an even 40, and the other roommate's was 22.05. That's how you do it. Done. 3 coworkers work for the same employer. Their jobs are warehouse manager, office manager, and truck driver. So just assigning random variables to each, we'll say X, Y, and Z in that order. So then it says the sum of the warehouse manager and the office manager is 82,000. So X plus Y equals 82,000. Next it says the office manager makes 4,000 more, meaning 4,000 plus the truck driver. And then it says the annual salaries of the warehouse manager and truck driver. So warehouse and truck driver is 78,000. Okay, so we have our triple system and now we can solve. So of course, I'd love to get 2 equations with just 2 variables. So I can do that with a little substitution, right? I got x plus z equals 78,000. I can also plug this into the first equation. And then I get x plus 4,000 plus z equals 82,000. But then when I subtract both sides by 4,000, I get x plus z is equal to 78,000. And then I have the exact same equation here. So obviously, if I try my typical elimination, multiply by -1, add them together, we get 0 equals 0. And you know when you get a situation like that, this means there are infinite solutions. So since there are infinite solutions, we need more info. So we'll say we need more info, infinite solutions. That's how you do it. Done. A local band sells out their concert. They sell all 1175 tickets for a total purse of that, 28,000 whatever. The tickets were priced at $20 for students, $22.50 for children, and $29 for adults. So these are going to be the three categories: students, children, and adults. But we're not going to use these variables. I don't like S as a variable, so we'll just say X, Y, and Z. And we've got these different prices, so I'm just going to put that $20 price here. We're going to put the $22.50 here. I just like setting this all up in a table, right? So we can reference it easily. And then $29 per adult. So the first equation we can set up is $20 per student plus 22.5 per child, right? For the total amount of money, plus 29 per adult equals a total of 28,112.5. And then it says if the band sold twice as many adults as children. So that means if I multiply the children by 2, I get the number of adult tickets, which is Z. And then we also have a third equation with this amount. That's the total number of tickets, which is just straight up X plus Y plus Z equals 1175. Now we have a triple system, 3 variables, 3 equations. We got enough to go. Let's do it. So since I have a Z equaling 2Y here, I'd love to combine the top equation and the bottom equation to knock out the X, and then we can sort of start to work from there. So I'm going to make some more room. Then I'm going to multiply this one by -20. That'll allow me to cancel out the X's over here. So then I get -20X minus 20Y minus 20Z is equal to, I can do this mentally, so if we double it, it's 22, 23, 50 negative. But then we have to add on a 0, right, because we're multiplying by 20. So I doubled it and added a 0. And then we keep this one as is. Now we're going to combine these together. X's are going to cancel out. -20 plus 22.5 is 2.5y. -20 plus 29 is 9z. And then this minus this, let's do that in Desmos. And there we get those two subtracting, 4,612.5. And look at that, we got 2 great equations. We got this and we got this. And now I can, I can use elimination, but substitution is going to be so great. I can just plop in 2y for z. So check this out. I got 2.5y plus 9 times 2y, right? Replacing the z with 2y. So 9 times 2y is 18y is equal to that number, 4612.5. Combined like terms, that's 20.5y is equal to 4612.5. Divide both sides by 20.5, like so. And let's do that in Desmos now. And we get a nice even 225. Again, this is number of people for a certain category, so we shouldn't get any decimals or fractions. So that means y equals 225. And that's the number of children. So 225 there for children. Now I can easily get z because z is just double y. So double that is exactly 450. So that's the number of adults. And then last but not least, all 3 of them add together to get 1175. So if I add this plus this, that's 675. And then plus x is equal to 1175. Subtracting 675 from both sides, we get an even 500 for students. So the final answer is 500 students, 225 children, and 450 adults. That's how you do it. Done. Last year at Haven's Pawn Car dealership for a particular model of BMW, Jeep, Toyota, one could purchase all 3 cars for a total of $140,000. So we're going to give variables X, Y, and Z to represent each of these. So if these represent the prices, we have our first equation. Adding up all 3 cars gives us $140,000. This year, due to inflation, the same cars would cost this. Okay, so let's see how we can use that in a second. The cost of the BMW increased by 1.08%, or by 8%, which is basically like multiplying it by 1.08. So 1.08 times X. The Jeep went up by 5, so that's like multiplying it by 1.05. And the Toyota went up by 12%, which is like multiplying it by 1.12%. And then the new total is going to be 151,830. Finally, we said if the price of last year's Jeep, which is Y, and then again was, that's a to be verb, so that's equal to 7,000 less than the price of last year's BMW, which is X. And what was the price of each of the cars? All right, we got 3 variables, we got 3 equations. Let's go. So making a little bit more room, we see that I have Y and X in this third equation. So I'd love to combine these two in a way that would get rid of the Z's. That's pretty easy because I can just multiply this top one by negative 1.12. That will give an opposite coefficient to here, which will allow us to cancel it out. So let's write that out. Negative 1.12x minus 1.12y minus 1.12z is equal to, looking at it in Desmos, 156,800, negative, of course. And then we're going to leave this equation as is. Now we're going to add these two together. These, of course, are going to cancel out. Negative 1.12 plus 1.08, that's negative 0.04x. Here we have negative 0.07y, right? 1.12, basically minus 1.05, or, that negative plus that positive. And then this equals basically this minus this, right? But our answer is going to be negative, and it's negative 4,970, I believe. And then now what we can do is I can substitute this in for y down here and solve for x. So we got negative 0.04x minus 0.07, and then I'm replacing the y with x minus 7,000 is equal to 4,970. Let's make a little more room. So then as we distribute, we get negative 0.07x, and then 7 times 7 is 49. Again, that's a negative times a negative, so it's 49. 7 times 7,000 would be 49,000, but then it's 0.07, so we move the decimal over twice. That would turn into 490, of course, equals 4,970. Now let's combine like terms. That's negative 0.11x, simultaneously subtracting both sides by 490. Whoops, and it looks like I dropped that negative. Let me put that back up there. So negative 4,970, and then it's basically minus 490, which is like adding, because they're both negative, which is negative 5460. Last step, divide both sides by negative 0.11. And then we get 49636. And I think they rounded to the nearest dollar in the back of the book, so we'll do the same. So we'll write it up here as x equals 49,636. All right, so that's the first value. And then moving this back up here, we can write that like this, 49,636. Okay, now let's find y. So y is just 7,000 less than this, so I can just subtract by 7,000, and we get 42,636. And then going back to this equation, since they all add up to 140,000, I can add these together and subtract them from 140. Let's do that in Desmos. So you minus them and you get 47728. But the thing is, I think in these answers, when they did this calculation, they didn't round it so they kept it with like that trailing decimal. So you see now when you do it, you get 47,727. And that's what they get in the back of the book. So just, be mindful. They use the unrounded values in the calculation. So the last one for the Toyota is 47,727. And that is how you do it. Done. You inherit $1 million. You will invest it in 3 accounts for 1 year. The first account, we'll say first account, pays 3% compounded annually. Second one pays 4%, and these are all compounded. And the third one pays 2%. And again, we're going to put an X, Y, and Z, and this is going to probably represent the amount that you invest in each. All right. And then it says after 1 year, you earn 34 G's in interest. If you invest, okay, so let's first make an equation for that. So the amount of interest we're making is the percentage, right? And this is just 1 year. So even though it's compounded, it doesn't matter really. It's just basically like simple interest. So we have 0.03 times X plus 0.04 or 4% of Y plus 0.02 or 2% of Z is equal to that total amount of interest, which is 34 G's, okay, or 34 grand. If you invest 4 times the amount of money into the account that pays 3%, compared to 2%. So what that means is the amount that we invest in X is equal to 4 times what we invest in Z. So X equals 4Z. And then we have to come back to this original statement about the million, meaning the amount we invest in all 3 together, X plus Y plus Z, is $1 million Now we have our nice little triple system of equations. So the first thing I'm going to do is I'm going to try and line this one up with this one and knock out the y, because this one is only x and z. So if I can do that, it's going to be a lot easier. So let's make some more room. And I'm going to do two multiplications. I'm going to multiply this top one by 100, and then I'm going to multiply this bottom one, since we're trying to get rid of the y, I'm going to multiply it by -4, because this is going to be +4 when we distribute, so we're going to make it a -4. So the top equation is going to be 3x plus 4y plus 2z is equal to 34, and then we already had 1,000, we just add 2 more zeros, so that's 3,400,000. This one's going to be -4x minus 4y minus 4z is equal to -4 million. Now we add these together. Those are going to cancel out like we wanted. -4x plus 3x is -x. -4z plus 2z is -2z. And then -4 million plus 3,400,000 is -600,000. Great. Now, since I know that x equals 4z, let's do a little substitution. So instead of x, I'm going to say -4z minus 2z is equal to -600,000. Let's combine like terms. -4z minus 2z, that's -6z is equal to -600,000. Divide both sides by -6. We can do that mentally. And z equals 100,000. So 100 grand is invested into this 2% annual return account. Okay, boom. And now we can get what's invested in x, because x is 4 times that. So that's 400,000 in the 3% account. Last but not least, since everything adds up to 1,000,000, 100 plus 400 is 500. So the remaining in the 4% account, which has the most money invested, is 500,000 or 500,000. So those are your 3 answers. Done. The top three countries in oil consumption in a certain year are as follows: US, Japan, and China. So those will be our 3. And we'll just label them X, Y, and Z. Okay, in millions of barrels per day, the 3 top countries consumed 39.8% of the world's oil. Okay, we'll make an equation with that in a second. Let's just first read a little bit more. The United States okay, so it looks like these are representing percentages of the total, right? So that's what these are. And so actually we can just straight up add them together. So X plus Y plus Z is going to equal 39.8. And this is in percents. And then the United States consumed 0.7% more than 4 times China's consumption. There's a second equation. And then we need the United States consumed 5% more than triple Japan. So triple Japan's plus 5. Again, these are representing, X, Y, and Z are representing percentages. So I'm not taking like 5%. I'm just saying, oh, 5% more, I mean I'm literally add 5. Okay, now we got a triple system. We got 3 equations, 3 variables. Let's do our thing. So since I got an equation here with just X and Z, I'd love to combine this one with this one to just have X and Z as well. So first, let's get this as X minus 3y is equal to 5 by subtracting 3y from both sides. And then if I want to cancel out the y's, I'm going to multiply this top equation by +3. So then I get 3x plus 3y plus 3z is equal to 3 times 39.8, which I think is 119.4. Okay, now we're going to add these together. That's going to cancel out. X plus 3x is 4x, so then we still got that 3z is equal to these two added together, which is 124.4. Now I got this equation. Well, look at this. I got something perfect to substitute. I can substitute that in for x. So then we got 4 times, instead of x, I got 0.7 plus 4z, and then I got plus 3z equal to 124.4. Then I'm going to distribute. I got 2.8 plus 16z plus 3z is equal to 124.4. We're going to simultaneously subtract 2.8 from both sides while combining like terms. So then I have 19z is equal to, let's see, that's 121.6. Last but not least, divide both sides by 19, and that gives us 6.4. So z equals 6.4. So that means China is consuming 6.4%. Now, since I know China, I can plug that into this equation right here. So 4 times 6.4, that's 25.6 plus 0.7, 25.6 plus 0.7 is 26.3. So X, or the US, is equal to 26.3 3%. Last but not least, we need y. And since all three of these together add up to 39.8, I can say 26.3 plus 6.4, that's 32.7. So 32.7 plus Japan, which is y, is equal to 39.8. Subtracting 32.7 from both sides, it would be, let's see, 7.1. So Japan is 7.1%. So here are the three answers: 26.3% for US, 7.1% for Japan, and 6.4% for China. That's how you do it. Done. The top three sources of oil imports for the United States in the same year were Saudi Arabia, Mexico, and Canada. The three top countries accounted for 47% of oil imports. So we'll say Saudi Arabia, Mexico, and Canada, and we're going to say X, Y, and Z. Now, if these represent actual percentages, which is what we're trying to find, if they say the top three countries accounted for 47, I can just literally add these three together and set that equal to 47%. So these are going to, again, represent percentages. So then it says 1.8% more from Saudi than Mexico, which means Saudi is Mexico plus 1.8, and then 1.7% more from Saudi than Canada. So if Saudi is X, Canada would be adding 1.7 to equal what they get from Saudi. So check it out. Now we got a nice triple system. Okay, so let's say we want to kind of like see this equation, which is a nice X and Y relationship. If I can combine these two to knock out the Z, right, then we're going to get a second X and Y relationship. And that's going to be done really easily when I subtract Z from both sides in this equation, right? X minus Z equals 1.7, and then we'll keep this one as is. So now we add these together and we get X plus X is 2X, Y stays Y, the Z's cancel out, and then we got 47 plus 1.7 is 48.7. So now we can do a little substitution, right? X equals Y plus 1.8. So I'm going to substitute in Y plus 1.8, and then we got plus Y is equal to 48.7. Distribute. Let's make some more room. And that's going to be 2Y, but I'm going to also combine it with that Y, which is 3Y. 2 times 1.8 is 3.6 equals 48.7. Subtract 3.6 from both sides, and 3Y equals 45.1. Last but not least, divide both sides by 3. And let's go ahead and do that in Desmos. And we get really close to 15, right? So we're going to approximate and just say 15%. So Y is equal to 15. So we'll say 15% looks like it's coming from Mexico. Okay, so then with that 15%, for Mexico, we're going to plug it in here for Y, and 15 plus 1.8, that's 16.8%. So that's Saudi is 16.8%. And then Z is 1.7 more, or sorry, Z plus 1.7 is X. So X minus 1.7 is Z. So since X is 16.8 minus 1.7 is 15.1% from Canada. So here are the final answers: 16.8 from Saudi, 15% from Mexico, 15.1% from Canada. Boom, done. At one time in the United States, 398 species of animals were on the endangered species list. The top groups were mammals, birds, and fish. So there we got X, Y, and Z representing those. And they comprised of 55% of the endangered species. Now again, these are going to represent particular percentages, right? It says what percent of endangered species came from mammals, birds, and fish. So first we know that if we add these three percentages together, it's going to be a total of 55%, right? And then it said birds accounted for 0.7 more than the fish is Z, and the fish accounted for 1.5 more than the mammals, which is X. Now you might be wondering about this number, but that looks like a red herring. I still always underline every number just in case, but we don't really need it here. Okay, now we got a triple system, 3 equations, 3 variables. Let's do our thing. And the first thing I'm going to do, since I have a Y and a Z here, again, kind of like arbitrarily isolating this one here, where I'd love to combine this with this and knock out the X, right? Because if we knock out the X, we get 2 equations with just Y and Z. So first I'm going to subtract X from both sides here. So we have negative X plus Z is equal to 1.5. Then over here, we have X plus Y plus Z is equal to 55. Now we're going to add these together. Those are going to cancel out. Y plus nothing is Y. Z plus Z is 2Z is equal to 55 plus 1.5, which is 56.5. Great. So now I have this equation. I also have this equation, y equals 0.7 plus z, I can just substitute that in. So I'm going to replace y with 0.7 plus z, and then we have still the 2z is equal to 56.5. Now I'm going to subtract 0.7 from both sides. That's going to be 55.8 is equal to z plus 2z, which is 3z. We're going to divide both sides by 3. Let's do that in Desmos. And we get exactly 18.6. So z is 18.6. So that's the amount of fish. So fish comprise 18.6%. And then to get y, we simply add 0.7 to that. So that is going to be 19.3 for the birds. And then last but not least, we need to solve for x. We got this nice equation here. I'm going to subtract 1.5 from both sides. So whatever z is, if I minus 1.5 from that, I'll get the percentage for x. So that's z is 18.6. 18.6 minus 1.5 is 17.1. So mammals comprise 17.1%, birds 19.3%, and fish 18.6%. That's how you do it. Done. This was a crazy section, and if you get assigned a lot of problems, I apologize. This took me so long. So anyways, thank you guys so much for joining. If you like this video, make sure to click that like button. If you want to see more from the Scalar Learning channel, make sure to click subscribe. Thank you so much, and I'll see you in the next video. Take it easy.